Hello everyone and welcome! My name is Andrew Mallet and you are just minutes away from learning to manage Ubuntu 2004 Linux systems. Let me introduce you to my very latest course, Ubuntu Linux Administration, Operation of a Running System. Now I'm the owner of the Urban Penguin within the UK, training and consulting Linux, and I have been doing so for many years. And I want to be able to transfer some of that knowledge to you good people out there. Currently, I'm working a lot with Linux and Python and configuration management systems such as Puppet and Salt. Ubuntu is a very popular Linux distribution and can be used not only as the heart of the LFCS exam, but also within the workplace and home. Some of the major topics that you're going to learn by following this course include bootloaders and starting Linux, managing software within Ubuntu Linux, shell scripting, and securing Ubuntu with AppArmor. By the end of this course, you'll know how to manage Ubuntu Linux on a day-to-day basis. But before you begin, you should already have some command line experience on Ubuntu up and running, some of which you might be able to find that you can pick up by taking a look at the Ubuntu Linux Administration Essential Commands course. Hello and a big warm welcome to you to this Pluralsight presentation. My name is Andrew Mallet and I'm going to be your instructor to help guide you through the course Ubuntu Linux Administration Operation of Running Systems. And in this particular module, we're going to introduce the course to you, but also take a look at controlling server shutdown and reboots. As we work our way through the complete course, we're going to be taking a look at how we can reboot and stop Linux, how we can start Linux and the grub bootloader, the grand unified bootloader. We'll be taking a look at managing services and managing the installation and removal of software, looking at processes and job scheduling. We'll be taking a look at security and mandatory access control lists with AppArmor. And in particular, this module, we're going to be focusing on the shutdown of Linux, how we can prevent logins by non-root users by use of the file etc nologin, and how we can reboot and power off the system. So when you're ready, strapped in comfortably, we're going to begin. Probably the first thing that we need to take a look at is the lab setup. Now, we went through the lab setup in a previous course. You might be looking at this out of order, so it doesn't really matter. But if you need information on how we've set the systems up, then go through and take a look at my course, Ubuntu Linux Administration and Essential Commands. We're going to be using Vagrant as a virtual machine manager and VirtualBox as our hypervisor. We only need one virtual machine for this, and we're using Ubuntu 2004. We're getting ready for the Linux Foundation Certified System Administrator, and that can be studied on either CentOS or Ubuntu, and we're using Ubuntu 2004. We're going to begin by taking a look at the shutdown command. So far, we've been concentrating on using Vagrant. This then can start our virtual machine, it can shut our virtual machine down, but it's then using the host command line interface, sending signals through to our guest virtual machine, but it's not working directly on the guest system. We, of course, need to focus on how we do this through Linux, not through the virtual machine manager, and that's what we'll be taking a look at now. Of course, concentrating on the Linux side of things, we can shut down or reboot a machine using the shutdown command. One of the great advantages of this is that we're able to schedule it at a time. Now, we can do it immediately if we want using the now keyword, and there are other keywords that we can use, such as midday, or even a cute one is tea time. -R is for a reboot, -H is to halt the system. plus 30 is doing it in 30 minutes time. We can cancel an impending shutdown, and we can also go through and do it at a specific time. Here we've got 17:30, and with all of these we can have a message that's going to appear on all of our users' consoles. If we need help on this, we can look at the man page. Man shutdown will be enough, but don't forget we have different man page sections. So section 8 is administrative commands, and shutdown, of course, is an administrative command. Now, another thing that we might be interested in is to prevent non-root logins. Creating the file etc nologin will prevent any user other than the root user from logging into the system. Now, this then can be quite useful. We might have rebooted a machine because we want to then be maintaining it, and we don't want users logging into a system. So after the reboot, we can create the file straight away. Once we've created the file, then no users will be able to log on until we've either deleted the file or rebooted again. The reboot process will actually go through and delete the file etc nologon if it exists. So at this stage, I think we're just about ready to get you out and practicing some of these commands. And we know the more you practice, the better you're going to be within your own environment and knowledge. So come on, why don't you join me in the next clip where we're going to take a look at managing our shutdowns. So yes, we always encourage you to join in these demonstrations on your own system so you're able to really get that practical experience that's going to be so important. So we're going to be taking a look at investigating system maintenance, and by that we mean being able to shut down and reboot your system, as well as prevent non-root logins during these maintenance periods. So come on, let's go through and find that command line. Hey, come on, it's just a command line. We've seen one of these before, but we should celebrate this. We're about to get stuck into some real command line learning. So we're working on our Ubuntu One system, and when we go through and take a look at our host name CTL, we should be able to see then, yes, it is Ubuntu 20.04 and patch level 4. We're only working with Ubuntu systems in this course, and we only need one Ubuntu system running for this module. With this up and running, we can go through and take a look at our man page, so man and shutdown, and we can see then that it's shutdown 8, looking in the top left-hand corner. This then indicates that it's a man page section 8. We don't need to specify the 8 as it doesn't conflict with any other man page. But you always like to be a little bit more accurate if you want, and could do a man 8 shutdown. When we take a look at this, we can use it to halt, power off, or reboot our machine. And we can see then that we often then provide a time argument. They're suggesting that the time string is often going to be now, although I'd say that's one of the advantages of shutdown, is that we can schedule an event to happen, even if it's going to be in the near future. With now, users don't get any opportunity to be able to finish what they're doing on the system. Our time can be specified as now, or we can also go through and specify it in different time formats. So we can go through and specify the number of minutes, so plus and then a number, or we can go through and specify it in our 24-hour clock format, such as 17:30, as we saw before. We could also, as they show, use +0 is an alias then for now. We can use -H to do a halt. We can use -R for a reboot. But we can also go through and use -P for power off. We're probably going to find -P and -H are more or less the same on all of our systems. Halting a machine used to be able to take it back to a BIOS prompt if there was a separate BIOS prompt existing on the system. But in most systems these days, power off and halt are going to be the same, as there isn't that BIOS prompt to take you back to. So we can use quit to get out of our man page. And don't forget, it's always a good idea to look at these man pages. When we look at the shutdown command, we can then use our shutdown -R, and we can see that if we just specify now, we've got no opportunity to be able to do anything. We can also see that it is an administrative command because it's not allowing us to do it without elevating our privileges. So it tried to happen straight away, but was unable to. But that reminds us then that we can go back and use sudo and exclamation mark. And if we remember from the Essentials course, this was a great way of repeating the exact same command and options, and is really good if we have omitted to put sudo in front. And we can really see now that, yeah, we had no opportunity to save any of our work. We were just thrown out of our system, as would every other user connected to this system. So whilst it's okay by using now or +0, we're probably better off making use of some of the scheduling events that we can use within Shutdown. Now, because this was a reboot, the system will be now rebooting in the background, and I can then go back and connect to it and carry on working. So there's nothing now preventing me, once the reboot has completed, to get back into my system. So using Vagrant, SSH, and then Ubuntu One, I'm going to be connected back via SSH back to my system. And of course, then that's going to allow me to look just a little bit more at some of the marvelous things that we can do with this incredible shutdown command. So we can go through and use sudo and shutdown, -H, then for our halt. And then we can go through and specify a future time. So if we add in +30, so in 30 minutes time, and then a message that will display on user consoles. So this system will be shut down in 30 minutes. Now we get a different message because we've issued this. Users would see the message that we've sent, but we're also going to see the message that we've scheduled the event and when it's going to occur, and the fact that we can cancel any impending shutdown with shutdown -C. We might even go through and try that now just to see that it will work. Although, to be honest, we're not going to hang around for the 30 minutes to see if it will, in fact, shut down. But we can go back now and do our shutdown -C. So any impending shutdown event now has been terminated. But if we go through and put, let's say, something a little bit shorter, or if we go through and put in +5, as soon as we get to less than 5 minutes, non-root logins are prevented from accessing the system. So what we don't want is new users connecting in. And we can see how this is done. And if I look at the ls and run directory, we've got a new file that's been created called nologin. Now we're going to see a little bit later on, it's sibling the etc nologin file. But as soon as any shutdown event is less than 5 minutes away, we're preventing new logins, because I say that's kind of the last thing that you want. You want to bring the system down and then people keep on logging into the system. So this way, as soon as we've less than 5 minutes, no user is going to be able to connect into the system. But to be honest, we still don't even really want to hang about for the 5 minutes for it to reboot. So there's nothing stopping us, if we really want to, shutting the system down now. So we can still go through and issue another shutdown command, even though we have one scheduled. So of course we could cancel it, we've already seen, but there's nothing then stopping me issuing a brand new shutdown command. So if I go back, I can clear all of this out. Let's go through and move it to the top. And we can see now that we've done the shutdown -H. So the system's not going to reboot. It's been shut down now. And you can see again, I've been thrown out. Now, of course, having shut the system down, I can go through and take a look with my Vagrant and status to see my virtual machines. And when we take a look at these, both machines are in a powered off state. None of them are rebooting or powered on. I can do this again just to say that they are definitely not restarting. So it's waiting for me to then go through and power them back on. So I can do that with the Vagrant up command. And I say we just need the one Ubuntu One system up and running. We can cut the boot process out. We don't really need to see it. But once it has then started up, I can go through and SSH back into the system, because there's one more thing I want you to be able to take away. We want to take a look at creation of that etc, a new nologin file. So if I do a sudo -I, that gives me then my root shell. I can then use the echo command. And we can have a message. I'm just going to say nologin, but you don't even need any content, but send it through to a file, etc nologin. If this file exists, non-root accounts cannot connect into your system. If you were logging onto a console, you would see the contents of that message, but via SSH, you're not going to see the contents of that message. But if I try from a different window to be able to log into that system, you can see then that I can't connect into Ubuntu One. I'm still logged in through my original window. But the other thing I want to point out, if I do a reboot, so if we do a shutdown -R, okay, I'm going to implement it now. Let's say I've finished with my maintenance. Upon reboot of the system will remove the etc nologin file automatically. So the idea is that you create the file after it has been restarted. If you create it before you reboot the machine, upon reboot, it's deleted. But it allows you then to maintain the system without users annoying you. And we can see now that we're back into our system and we didn't need to delete the file. So hopefully this has been a good introduction to maintaining your system, and you've had some great practice and you understand a little bit more about the shutdown command and the etc nologin file. Hello and welcome back to our slides where we can take a look at some other commands that we've got, the Poweroff and the Reboot command. This is one of the reasons why I say with the shutdown command, I don't think we necessarily are going to use it that often with the option -now, because we have other commands that will allow that to happen. If we look at the Poweroff command will do exactly as it says on the tin. Of course, we need sudo privileges to be able to do this, but it will power off our system. Which Poweroff is going to list the file or the path to the file. If we look at an ls-l on it, we can see that Poweroff itself is just a symbolic link to systemctl, our main service manager within Ubuntu and other more modern systems such as CentOS 8. If we look at the man page for Poweroff, we'll see that it's really the same for Halt and Reboot and Poweroff. It's all as one, but it's then just read by the command that we use to access it as to what options are going to be used with the command. But it happens immediately, and then it's probably a better option than using shutdown -H and now because it's just easier to type. So we don't need to schedule the event, then we can go through and use it directly from the command line with Poweroff or Reboot. But why don't we really go through and see some of this in action by looking at the Reboot and Poweroff command. So Reboot and Poweroff. And where is the command line? The command line is right here for us. Now we can begin by just taking a look at the which command. So if I go through and just type the which command by itself and go which power off, we're going to search through our path statement to see which command that we would run. Being in the sbin directory, it's a supervisory binary, so an administrative command. But that gives me the path, so we have a little bit of a shortcut if we want to do a long listing of that file. Rather than first checking the path and then listing it, what we could do is look at the output of which Poweroff, and once we've got that inside of our brackets, the brackets are going to be interpreted first and will populate a temporary variable, and then of course we get a long listing of USR sbin Poweroff. And we can see that that is a symbolic link to /bin/systemctl. The systemctl then is our main service manager. When I go through and take a look then at any of the commands, so if we go through and look at, let's say, Reboot, and we can do the same thing with, say, Halt, we can see that they are all really pointing to the same underlying command through a symbolic link. When we take a look inside of the actual man page, if I go through man power off, it seems to have opened up the Halt man page, but really it's Halt, Poweroff and Reboot. Really it is all of the same system. So we can either run the Halt command, Poweroff and Reboot, but irrelevant of the command that we run, we can always go through and specify an option for the underlying command that we want. So this is all just a little bit weird. But again, it's really indicating that they are all pointing through to exactly the same program. If I go through and just use the quit command, so Q to get out of the man page, then if I do just want to simply reboot the system, this is where I kind of say that we don't need to, if we need to do it now, then we're just going to do a sudo and reboot. We're not really going to do the shutdown -R now, because this is just so much easier. So the effect is exactly the same. The users get no notification, but we're now going through that reboot stage. So I think the shutdown command is great because we can schedule events and that can give notification to users. So a system where users are connecting to it. Whereas if it's not a system that users connect to, then they're not going to get those messages coming through on their console. So it becomes less important and we may be able to just bring it down immediately. We want to bring it down immediately, then we can just make use of these reboot or halt or power off commands. Again, this is a reboot event, so I should be able to log straight back in and we'll be back in at our system. Remember, I could also go through and actually check that it has rebooted. If we look at the uptime command, we can see then that I've been up for less than a minute, so 0 minutes. We can see our load averages, and our load average gives an indication of how busy our system has been. The first one, 0.42, is our load average over the last 1 minute, which is really indicating that we've been relatively busy, about 50% load, as we've been starting up our system. If I look at the uptime again, though, we can see that we're gradually dropping as we're starting to do less, and our system now has been up a clear minute. But we'll look at later on in this course, we'll take a little bit more monitoring our processes and our performance to get a better understanding of what we're actually looking at with those load averages. But there you go. We've seen then that we've got the simple commands reboot or power off if we need to get our system rebooted or powered off immediately. So let's return back to our slides so we can just summarize a little of what we've taken our time discovering in this module. And look at this, a glorious summary. Wherever you see this lovely orange tinge, you congratulate yourself on having got to the end of a module. So congratulations. So we've had a course overview, what we're looking at in this entire Ubuntu operating a running system course. So in this module, we're looking at rebooting and stopping Linux. In the next module, we're going to be taking a look at starting Linux. So the grub bootloader, our grand unified bootloader, and how we can go through and modify the startup procedure. Once we've done that, we can go through and start looking at managing services and managing software installation. We also need to look a little bit more time at managing our processes and job scheduling. So with that, we'll be looking at a little bit more of the PS command, but also the uptime command to see how busy our system has been. With job scheduling, we can be looking at things such as systemd timers and the cron job scheduler. Using AppArmor, we're able to add to the security of our Ubuntu Linux system. AppArmor we're going to find on things like SUSE Linux and on Ubuntu-based systems, and is a mandatory access control list where we can even control what rights root gets to certain files or directories. In particular, in this module, remember we were concentrating on rebooting and stopping Linux. So we were looking at the shutdown command and looking at the fact that we can use the shutdown command when we want to reboot or shut our system down, but probably in a future time. So maybe in 30 minutes or so, so plus 30. We can display messages to our users so they can get some form of warning of the impending shutdown. We can also prevent users from logging into our system by creating the file etc nologin, but be aware that's going to be deleted upon a reboot. So we need to start our system and then quickly create that file to stop users logging in. This is great when we need our system to be maintained and we don't want users connecting to the system whilst it's being maintained. Rather than using the shutdown command with the option now as the time frame, we've got reboot or power off. And this then really is doing the same thing, but just really making the command just that little bit more concise to be able to type. And that's it. We're done and dusted with this module. But don't forget, we've got some wonderful content coming your way. And we're saying in the next module, we're going to be understanding our grand unified bootloader, Grub. So please join me in the next module where we're going to learn all about our boot options. Hello and welcome to this Pluralsight presentation. My name is Andrew Mallett and I'm here as your instructor to help guide you through the module Understanding the Grub Bootloader. So when you're ready, sat comfortably, we're going to begin. Now, of course, we're looking at the grand unified bootloader and how we can start up Linux. So we'll be taking a look at booting Linux, and we'll see that we load both an init ramfs as well as the kernel. And we'll be looking at how we can make modifications to the kernel with our kernel parameters. We'll look at our grub configuration. With this, we can make permanent changes to our kernel parameters that are being passed. And we'll also look at being able to temporarily change the boot process by booting into different targets or with different kernel parameters. We'll see if we have problems with grub. We could reinstall the grub bootloader. as well as looking at the recovery options that are available within Grub. So this is what we have on our menu, and I do hope it's going to match with what you're expecting. So come on, let's make a start. Now, the very first thing that we're going to be taking a look at is booting Linux. And when we're looking at a physical machine, we would first load the BIOS. This is going to look for a bootable disk. Now, on an ordinary desktop PC, the BIOS loading is probably quite quick. It doesn't really take very long. But obviously on a server-based system, this can take much longer. But we also have to be considerate of our modern environments, where very often we're using virtual machines or we are using containers for our servers. So in some respects, this doesn't matter so much. We also have a Grub bootloader. The Grub menu is likely to be displayed, and that can give you recovery options or different versions of the kernel that you could boot to. Once we've selected an item from our Grub menu, then Grub is going to load the selected kernel and the initialization RAM FS. The initialization RAM FS have enough drivers to get your system up and running, so we don't need every driver built into the kernel. Once the kernel is loaded, any additional drivers that it does need, it would be able to access from our root file system. But we just need to make sure that the init RAM FS have the drivers needed to be able to access the root file system. Now, working with our Ubuntu systems, I've set this up within Vagrant, so we need to configure the Grub menu to display. By default, it doesn't display because it's hidden and it has a 0 timeout, so it just boots straight away to the default entry. Normally, the configuration is going to be in etc default grub, but we might also have to be wary in these systems we do that any settings that we have in etc default grub are not overwritten by configuration files within grub.d. So once we've made the necessary changing, and we'll see this from the command line later, we then need to update grub. We can do this with the update grub command, or we could do grub mkconfig and specify the grub configuration to overwrite. But update grub does this all for you, so it's a really simple option. So what we need to do now is make sure that we get ourselves prepared to dive out to our demonstration system and learn how to get our grub system displaying. Come on, I'll see you in 5 at the command line. So yes, we're going to dive out to the command line, and remember, I always emphasize the term we, because this is your learning experience as well. And we're going to take a look at configuring grub. We want to be able to see the menu within our Vagrant system. Remember, the Vagrant really is meant to hide a lot of what's going on in the background, and as part of that, there's no need for the grub menu to show. So we want to set a timeout so we can then have time to adjust this and make sure that the grub menu is correctly displayed. So come on, let's go through and find our demonstration system. Now I just want to display what's happening by default. So I've opened up VirtualBox and we have to then locate our machine. I can see this is my Ubuntu One machine. Yours might be named slightly different depending on the directory that is located in. But we can then go through and right-click on this. We can go through to Start, and then a normal start. And we can see then that it begins to boot. But we're not seeing any grub menu, and it just starts loading straight away. And it's this behavior that we want to be able to understand. Certainly, if we're going to understand a little bit about grub, then we need to be able to see what the bootloader is. Now, of course, if you're working a lot with cloud systems, then you're never going to be able to see the bootloader because you're always connecting via SSH or some other remote access protocol. So you're never there during the boot phase. But on these virtual machines where we have local access to it, then there certainly are ways in. So I'm going to navigate back through to my command line. I can clear out my screen. This is just running on my host system. And then we can use Vagrant and SSH to the Ubuntu One system. We know that it's booted now, but we've got to change its configuration. So I'm on the system, and we can go through and clear out my screen. We can elevate our privileges and run as sudo and vim /etc/default and then grub. So if we take a look at this file, it's setting a lot of the default settings for our grub bootloader. The timeout here is then how long the menu is going to display before it chooses the default entry. Default entry 0 is just the first entry. So I can move to the end of the line. Uppercase A is going to allow me to append at the end of the line. And I can then go through and maybe put a 10-second timeout. Now we can also see the timeout style here is hidden. So we would just wait 10 seconds, but we wouldn't see anything. We want to display the menu, so we can go through and add the menu in there. Once we've done that, we can go through and save our changes. But we also have to be aware that there is a grub.d directory inside of default. And we've got some extra files that can overwrite settings. If I go through and take a look at 50 cloud image and take a look at this, we've got then our grub timeout again. So that's being set. So I'm just going to delete it from here. So we are picking up on the timeout that I set for 10 seconds. I can go through and save the change. And with that done, we need to then update our configuration. I can run a sudo and grub-muck config. If I just run it, it will print the config to the screen. So it reads all of the default settings and any other configuration it's got and merges it into a configuration file. But it prints to the screen, so it's not really doing anything. If we wanted this to write, we would then use the -o, and the grub configuration file we need to use is /boot/grub, and then the grub.cfg. But there is a quicker way of doing this in Ubuntu, and that's sudo update-grub. So it does exactly the same thing, but it's just an easier mechanism. We show you both ways because on other systems, they might not have the update grub. But remember, we are concentrating on Ubuntu here, and we can then just use the update grub. Now, with that done, if I go through and do a sudo and reboot, and then go back to my virtual machine, now, as we boot, we can see then that I've got a menu being displayed, and I can up arrow and down arrow key. Once I've started using the arrow, it's going to stop the timeout anyway, but it gives you an idea of what grub is all about, and then how we can start making some changes. Obviously, we want to investigate being able to make some of these changes, so this is what we're going to be taking a look at when we come back in the next clip. Now, of course, we know a little bit about grub now, but we're going to delve a little bit more just to see what happens when we actually boot or load our Linux system. Now, of course, we can probably guess that the kernel is going to be loaded. This is our core operating system, but it doesn't have all of the drivers built in. Many of those drivers are going to be loadable from either the usr-lib or usr-lib64 subdirectories. But this gives us a problem. how do we access that file system if we don't have the drivers needed to access it? And this could include things like our disk drivers, our host bus adapter drivers, as well as file system drivers. So that's where the second file comes in, the init RAM-fs, our initialization RAM file system. This is customized to have enough drivers to provide access through to our root file system. We can access the root file system, we're able to access then the additional drivers inside of USR-lib or USR-lib64. The initialization RAM-fs, though, only needs to be loaded during the initial boot phase, where of course the kernel stays running for the lifetime of that Linux boot. So why don't we dive out now to our demonstration, where we can go through and take a look at our grub bootloader and investigate what's inside of grub. So we'll see it pointing through to our kernel, we'll see it pointing through to our initialization RAM-fs, and we'll also go through and take a look at our /boot directory. And here we are, if not on the glorious command line, inside of our grub menu. I've booted the system and I've just paused the timeout, and we can do that just using the up arrow key or the down arrow key. So this allows us then to take our time over the selection. We've got our default entry, which is Ubuntu, as well as having advanced options which we can use for recovery, which we'll look at later. But we can also see a little bit of text towards the bottom that gives me some idea of how we can control this. Hitting the key E, we're able to get inside of the Ubuntu entry and see what sits behind the menu. Now, of course, there is a little bit here, and it is more complex than it used to be in previous versions. But if we move down, we can see that we've got an entry for Linux. So this is pointing to the core operating system, or our Linux kernel, that we're going to use. And of course, we can have parameters such as our root file system, the UUID of our root file system that follows. Below the Linux entry, we have the initialization RAM-fs, or the init-rd, the initialization RAM disk as it shows here. And this then holds those crucial drivers to allow our kernel access to the root file system. Now, if we want to continue booting our system, again, we can see the entries on the screen there, and we can use either Control and X or F10 to continue the boot process. Our boot process now then goes through, and this is normally what's going to be hidden from us during, let's say, Vagrant. We don't get to see this side of things in the same way as if you're using a cloud-based system, you're not going to be able to see your cloud-based system booting. But we can see now that we're on our physical console. We can see in the top left-hand corner, it's marked as TTY1. Normally, we've been connecting via SSH to a pseudo terminal, but we can log on then to a physical console on our host. And again, I'm going to use the username Vagrant. The password is exactly the same, so I can type in Vagrant in lowercase for the password. And now we're up and running on our system. Control and L will allow me to clear the screen just as it does before. And again, when I go through and look at TTY, we can see now it's /dev/TTY rather than the PTS, our pseudo terminal. But whilst we're here, we're not going to spend a lot of time here because we don't have so much control over the font, but we're going to be able to take a look at where the kernel is and where the initialization RAM disk is. If I do an ls-l of /boot, we can see then that we've got symbolic links that points to our current RAM disk, our current kernel, and previous versions. In our case, they're the same version as we haven't updated our system. But if you've got older versions, you'll find the links will point to different versions. And it does allow us then to be able to boot into a previous operating system if we've had a previous kernel that worked well for us and perhaps a kernel update isn't working as well for us. We also have the grub directory. The grub directory is where the grub configuration is being loaded from. So we're able to see all of the information that relates to our boot process, the kernel, the RAM disk, as well as the grub configuration sitting inside of the grub directory. Now come on, let's return to our slides. Now where we have our Linux line in the grub configuration, we have parameters that follow this, and we can pass additional parameters if we need to. If we put init equals /bin/bash, then we're saying then don't start the system normally, start the system with a bash prompt. It's automatically going to be logged in as a root user, so we don't need to authenticate. Now this can be very useful where we have then lost our root user's password, or perhaps in Ubuntu we've never set our root user's password, so it doesn't have a password. Now although we gain access using sudo, if we've broken our sudo system, then we can recover our system by gaining access as root. Once we have set the root password, then we can carry on our boot process running the init command. So come on, let's go through and take a look at this really important demonstration where we're going to see the use of kernel parameters. So we're going to boot to the bash shell, recover our root password, and continue our normal boot process. Now again, I'm going to use that same option, E, to get into Edit My Grub menu. I'm going to navigate down to the Linux line. Now that I've found the Linux line, I can use Control and E to quickly navigate to the end. So Control and E moves me to the end of the line. And then from here, we've got a couple of entries for the console that I'm going to remove. We don't need these, and they will interfere with our boot process. And I'm going to change the read-only entry to read-write. And then importantly, this is what we really need to add in, init equals /bin/bash. So we're just going to start up to the bash prompt and no other services as far as Linux is concerned. But it will give me access as a root user without me having to authenticate. So this allows me to easily recover from a lost root password or lost access to root. In these situations, there are no root passwords set in Ubuntu anyway. Now we boot up to our root prompt, and I can just use Control and L to move that to the top of the screen. But now I've gained access without needing to authenticate. I can then go through and change my password or reset the password. So I can just use passwd. Being root is not going to prompt me for the current password, so I'm able to set it to anything that I want. And now I've been able to recover from perhaps a lost root password or perhaps a broken sudo system. We can continue the boot process now using exec and sbin and init to continue the normal boot process. So we're going to then continue loading all of our services as normal. And of course, then I'm going to be able to test and make sure that I'm able to log in as the root user. So root, and then the password that we've just set. And we then gained access to our system now as our root user. So very, very simple, but great use of physical access to the console and being able to reset or recover your situation from a broken sudo system. So something really important and something you're going to be able to make great use of, I'm sure. Now, where we made the change before, inside of the grub menu itself, this is transient. It's not going to stay. If you need to make an entry that is going to persist, then we can add our own custom grub entries. We can go ahead and edit the etc grub.d, and our custom entries will go into the 40_custom file. We add to the file appending to the end, and we don't change anything that is there. The editor that we choose to use is down to you, and use any editor that you are comfortable with. Once we've finished with the edit, we're able then to go through and update grub, which is going to add then those settings through to the main grub configuration. So we're going to take a look at how we can implement this now by moving out to our command line and seeing how we persist our grub entries by creating our own custom entry. I have my system back up and running at this stage, and we can see then that I've SSH'd into the system, and we're going to begin by going through and using sudo and vim. Now I'm using the Vim text editor, and I'll explain what I'm doing as I go through. I would encourage you to use whichever editor you are comfortable with, but we can just do a little bit more with Vim, and getting to know Vim may be a good option for you. I'm going to look at them /etc/grub.d, and then we can move into the 40 custom file. As I hit enter on this, we're warned not to make changes to the top of the file. So I can use uppercase G to go to the end of the file. And then I'm going to go through and use escape and colon. And at the colon prompt, I can type R to read in. And I can read in from the /boot grub and grub.cfg file. Now, of course, I don't need all of this file, but it's very easy to clear some of these entries out. I'm going to go and write 130dd. So I've just deleted 130 lines. Sounds a lot, but I knew roughly where I wanted to go. I want the menu entry line. So I just need to delete a few more lines. So DD, 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 DD deletes a single line. Once I've got through to the menu entry line, then I'm good to go. So that's the menu entry. I'm going to move down to the line that says submenu. And we don't need this. So I'm going to use D uppercase G. D uppercase G deletes to the end of the file. So this is where I say that Vim is quite powerful. It's very easy for me to be able to read in from another file and quickly edit this file. Now I'm going to change the menu entry name. And we can change this, let's say, to recovery. So I hit I for insert. And then I can delete then the word Ubuntu and replace it with the word recovery. So it will show as recovery in the menu. I can move to the Linux line. I'm just going to hit escape to take me back to my normal mode. And then I can use uppercase A to append at the end. Again, I want to delete the existing entries all the way back to the UUID. So I keep that for the root file system. And we put then we want to go into read write. And in it equals /bin/bash. Now I'm not saying you really need this entry in your system, but it does then give you a very easy situation from the console of the system to be able to get in as root should we need it. Everything else is going to be the same, and it really is only the kernel parameters that we are likely to be changing. Once I've done this, I can double check that everything looks okay. So I've got my menu entry. The menu entry itself is then encapsulated inside of my brace brackets, and make sure you've still got the closing brace bracket. I can escape and save my changes. Now say if you're using Nano, you just have to be more careful about the edits and making sure that you are deleting the lines that are required, or look at other ways of cutting and pasting the information from the original grub CFG. But with that done, I can then go through and do a sudo and update grub. Hit the big enter key. So it will have generated the new grub configuration. And now we can go through our boot process again. So I'm just going to do a sudo and reboot. Now we can see then on the boot, we've got our Ubuntu entry, which is still our default entry, but we can also then have our submenu for advanced, and we have then our new menu entry that we added in recovery. And this is then the same init equals bin bash as we had seen before. So this is going to allow me to boot up to gain root access directly. We've also got some recovery options built in underneath our advanced options for Ubuntu. And we'll be taking a look at this in our next clip. Now, the astute among you may have already noticed that we have that advanced submenu. We can go through and navigate through to that. And one of the options we have underneath that is our recovery menu. And of course, the recovery menu, as the name might suggest, gives you access to some of our repair tools. Now, we're going to be able to investigate this just a little bit further, and it's probably best to go through and open up our grub menu to go through and see what tools are provided. By investigating these built-in repair options and seeing what's available in that submenu. And here we are then back at our main grub menu. And as we can see, we've got the advanced options for Ubuntu, which we haven't so far taken too much of a look at. So we can move into this, and it's a submenu, so we get then other entries showing, including the standard kernel that we could boot to. But if we take a look at the second entry, this is our recovery mode, and this has some built-in tools that we're able to use. So as we go through and allow the boot process to happen, we're going to be presented with a menu. Now, at this stage, you're going to think, wow, this looks a little bit untidy. How am I meant to read this? Problem is, we're still getting some extra messages being reported after the menu has loaded. But if we just move down to something fairly innocuous, such as updating the grub bootloader, we can hit OK on this. It tells us we're going to mount our file system in read-write mode because we can go through and run that update grub command. So we can see we get exactly the same options as we saw from update grub. But now when we go back into our menu, we can see now that we've cleared all of that superfluous information from the display. So just be aware that it might show incorrect the first time, but if we go into an option and then return to the menu, we're going to be able to see it nice and cleanly, such as this. Talking about clean, we can go through and try and tidy up some free space. If our root file system has become full, we might not be able to boot, so we can look at replacing some files. For our Debian packager, this is our software manager within Debian-based systems such as Ubuntu, and we can repair the database. And of course, you can see just below that, we have our file system check. So we can go through and check file systems. As we've seen, we can update our bootloader, but there are more tools to this as we will show you later. It's not just updating the configuration, we are able to reinstall grub. But of course, we wouldn't be able to get to this menu if grub was corrupt, so they don't put it available to us here. We can see that we've got then options to enable our networking. So if we wanted to copy files to our system or from our system, we might need networking enabled. We can open up our root shell. So this is what we were doing before with our init equals bin bash. And we can take a look at the system summary. If I just hit enter on this, it prints out information such as my CPU. We can go through and take a look at the disk usage, but we can use the page up, the page down, or the tab key to go through and start selecting options from here. So if I go through and page down, we can see then below our disk usage, we've got things like software RAID, our logical volume if they're enabled, our memory utilization. We see we don't enable networking at the moment, but we're able to see our system database for APT. That's really our Debian package database, and that looks good, so we're able to continue. So a good system check that's available to us. But it shows us then some of the things that are available to us. Obviously, the top option here, resume, will allow me then to go through and resume a normal boot process. And it's just showing me now, as I've selected that we're going to go through then and load our normal drivers and continue our boot process. So hopefully this has given you an idea of some of the things that are available to us, but we do need to look a little bit more at recovering maybe from a failed grub bootloader. The options that we see there to be able to repair the configuration means that grub itself was okay. We're just updating the grub configuration. If the grub loader couldn't boot, then we wouldn't be able to display the grub menu. So we'd need to boot to maybe an installation DVD or an installation ISO file, and then choose the recovery options from there. And we'll take a look at how we might do something like that in our next clips. Grub itself is a little bit of code that is installed into our master boot record of our disk. Now that itself becomes corrupt, we're not going to be able to get to our grub menu to choose any of our recovery options. So there has to be another way that we're able to do this. If we choose to boot from the server install ISO file, I'm just going to have the Ubuntu 2004 server install ISO file. Now that's going to be fine, but it will default to boot into an installation. So as we start the DVD, when we're first presented with the screen, just hit the spacebar and we're going to be able to see then a menu so we can choose different options. If we choose F6, other options, we're able to put our kernel parameters to boot to, as we've seen before, the init =/bin/bash. With that then we're going to boot up to our DVD, but it doesn't have all of the tools that we want. So we can mount then /dev/sta1, our normal root file system, to the /mnt directory. But we also need our devices. The devices are detected by our main operating system, in this case the ISO. So we can then remount them underneath /mount/dev. And that goes well with our proc to detect all of our processes and our sys directory. All of these are temporary memory resident file systems, but we need to make available underneath the mount directory. They need to be underneath the mount directory because we're going to change our root file system to point to the mount directory. So we want all our detected devices, processes, and system elements available to us. When we run chroot, we're also going to make sure that we run a bash shell. It's the easiest shell to use if we're used to this. And from there, we can run grub install. Now, we have to go through this process because grub install isn't available on our live DVD. So we have to then go through and get it from our main or original operating system. But we can install then grub to /dev/sta. We're then finished with this environment, so we can power off our system, and then we should be able to recover from the failed grub. But to really be able to see this, I'm going to encourage you for the very last time in this module to dive out to your systems so you can get some really useful hands-on practice. So booting to our live ISO, mounting our root file system, looking at the chroot command, and repairing grub. Now we're beginning with our virtual machine powered off, and we're assuming that we've tried to power it on and we've had problems loading grub. So our grub bootloader is corrupt. We need to move to storage. So clicking on the storage link, we can go to the empty DVD, and we can then go through and browse to a file we've used before, or choose a disk file if we haven't previously used an ISO file with it. Here I'm using the live server ISO file. And with that done, we can choose OK. If I right click and then start and normal start, we're going to be booting from that DVD. The first thing we must do is just hit the spacebar. This will pause the boot process and show me the menu. Hitting escape gets me out of my language options. And you can see then the options that are available to me, but we don't have a repair or a recovery. So what we can do is hit the F6 option. The F6 option will allow me to change the boot parameters to boot to init equals bin bash. But I don't have F6 available to me. It's not mapped through for my virtual machine. So I can go through in my virtual box menu and choosing input and soft keyboard. This will then display a keyboard on the screen, and all I need to do is just hit F6. With this done, I can just close the keyboard off again, and I won't need it again. The soft keyboard just gives me access to those F numbers that I don't have access to. I can hit escape, and then I can backspace to remove the dashes, and then I can go through and put my normal read write and init equals /bin/bash. Now we should be pretty used to this by now. So this is going to boot up to a bash shell, but a bash shell that's coming from our ISO operating system and not our core operating system. So once that has booted up, I can use Control and L as normal to clear my screen, moving the prompt to the top. We then go through and mount our main root file system, so /dev/sta1 through to the /mnt directory. Now that puts the files that we're going to need, but we also need the detected files during the boot process. So we can do mount --r bind. So we're remapping everything underneath the dev directory through to be available underneath the /mnt/dev directory. And we need to do this for our device directory, so we can have our devices running in our main operating system below /mnt. But we need to do it not just for our devices, but we need to do it for the /proc directory. We have several runtime directories that are created during the boot process, but we want these to be available to our main operating system, which is going to exist below the mount directory. So we do this for proc and mount proc. And again, we up arrow key and do the same thing for the sys directory. So this puts all of the runtime elements in our mount directory. And once this is in place, we can make this then our main root file system by using the chroot command. We're able to change the root directory from being the root of the ISO file through to our mount directory. So chroot /mnt, and we want to make sure that we're running a bash shell inside of our chrooted environment. So this is good, and then everything below our root directory is now going to be represented by the contents of the mount directory and the remap dev, proc and sys directories. This then makes available to us grub install. Grub install isn't in the server environment, so that's why we've needed to run through this process. We can reinstall grub, put the grub bootloader back into the master boot record of /dev/sda. We're doing SDA, not SDA1. SDA1 is the partition. Normally, we're going to have our grub bootloader installed on the disk and not the partition. We can exit out of our environment. If we exit, this is exiting out of our chrooted environment. Having exited out of the chrooted environment, I'm going to return through to my virtual box, and I can go through and power off the system from here. So I can then go through to close and power off, and our machine is now shut down. We can go back to our storage and make sure we remove the DVD and click OK. And now I can go through and restart my machine. So moving to the start menu and normal start, having reinstalled Grub. Now I know we didn't have problems with it before, but we will have now a new Grub bootloader installed in our master boot record. And of course, we've got access to the normal Grub configuration. So we've been able to recover our system, something really important if you do get a failure of your device. Now let's return to our slides so we can summarize a little of what we've seen. Look at this, the orange sunset on another module. A module where we've learned all about booting Linux and the Grub bootloader. So we took a look at the boot directory /boot. This is where we're going to be able to find our initialization RAM disk or init RAM FS. With this, we have the essential drivers to access our root file system. Control then can be given through to our kernel, and our kernel can pick up the rest of its drivers and modules from the root file system. But we also saw that we're able to pass parameters through to our kernel. This includes things such as the init equals /bin /bash. As we've seen, we can use this for many recovery options, including resetting of a root password. So if we've lost root access to our system through whatever mechanism, we're able, if we have access to the console, to reboot the system into our bin bash and then set our root password. But we also saw that we could use it for reinstalling Grub. Now, Grub isn't then going to be able to load if it's become corrupt, but we're able to boot from another live DVD into a bash shell, set up our environment so we're able to access the Grub install command, and then reinstall Grub. We also saw that if we needed to persist any of those kernel parameters, we could create our own custom Grub entries. But if we do make our changes through to Grub, we need to use the update-grub command to make sure we regenerate the grub.cfg inside of /boot /grub. But this is it. This concludes then our section on looking at booting Linux and the Grub bootloader. And I look forward to welcoming you to the next module where we can take a look at managing software in Ubuntu 2004. Hello and a big warm welcome to you to this Pluralsight presentation where we take a look at managing software in Ubuntu 2004. My name is Andrew Mallett and I'm going to be your instructor for this module as we step through the process of managing software with apt and dpkg. We're going to be taking a look at apt software repositories and installing and removing software from those repositories. The repositories themselves are detailed within the sources.list file and the subdirectory sources.list.d. We'll also be taking a look at the underlying dpkg command and .deb files which make up our Debian packager. When we take a look at software management as a whole in Ubuntu or any Debian-based system, we have our repositories. These are our online repositories that sit at the top of the tree. In this case, we then don't need to know the location of our package. We can then go through and install it with the apt command. The apt command then becomes our administrative interface to software management in Debian-based systems. Underlying, though, we have dpkg. This then works with the .deb files, which we're pulling down from our repositories with apt. Now, whilst we're talking about apt, did you know it has supercal powers? We'll just take a look at apt-help. With this, of course, we can get help on what we can use with apt. But we can go ahead then and see our Easter egg with apt-mu. Yes, apt-mu. But wait, we'll see this from the command line. You'll see exactly what we're going to do. Now also, you might get confused between apt and apt-get. So I can do things like apt-update to update the cache. I could also do the same thing with apt-get update. So what is the difference? If we take a look at running it remotely, so if I SSH into my second machine and run apt update, we'll get a warning saying that apt itself does not have a stable CLI interface and we shouldn't be using it within scripts or remote access such as this. So it's an interactive command that we can use from the command line apt. Whereas if we're running in script or running remote, we should be using the corresponding apt-get or apt-cache command. If I do the same thing remotely with apt-get update, we won't get that warning. So when we're running scripts, use apt-get. When we're running from the console itself, just use apt. Now, the best way to get an understanding of this, and don't forget the supercow powers, is to find our command line. We'll fire up both the Ubuntu 1 and Ubuntu 2 systems for the next demonstration. So yes, I'm going to really encourage you to dive out to the command line to work with both your Ubuntu 1 and Ubuntu 2 systems for this demonstration. Remember, it's the effort that you put in now that is really going to pay off when you're faced with the exam scenario. So come on, we're going to investigate apt. We can't leave without letting you take a look at those Easter eggs. We'll be taking a look at the difference between apt and apt-get. And we'll be looking at how we can run commands via SSH on remote systems, hence the need for running both the Ubuntu 1 and Ubuntu 2 systems. We can begin, though, by working just on the console of our Ubuntu 1 system. And here we are in the glorious pixel space that is Ubuntu 1. Say hello to Ubuntu 1 and get ready then for a little bit of help. So apt-help. Now, of course, this encourages you to look at some of the options that are available to you, so we can use some of the common options, such as listing, searching, showing, and so forth. But just take a look at the bottom line. This apt has supercow powers. And don't forget, we can clear our screen, up arrow key, and then pipe with the vertical bar, the output through to tail, minus N1, so we just see that last line. This apt has supercow powers. Well, what exactly do we mean by supercow powers? Well, I will show you. We saw it in the slides. We'll now get to experience exactly what apt-mu is. So not exactly a subcommand that's useful, but a little Easter egg that then asks, have you mooed today? So a little cow-say graphic. So something simple for us to look at. But it gets us started on a very light-hearted mood. When we go ahead and look at, let's say, apt update. With this, we would use apt update to update our local cache. Our cache is really the list of packages that are available from the online repositories. So when we do a search, we're really searching the local cache rather than the online repositories. Now we can see we need to upgrade our privileges. So we run it with sudo and bang bang, repeating the last command and arguments. And we can see using apt interactively from the console, we're not going to get any problems. And in the same way, we could run its sort of sister command, if you like, apt-get. Now, apt-get is really designed to be run from within script or remotely, as we'll see with SSH. So when we take a look at apt-get update, then again, we're not really going to see any difference when we go through and run it locally on the Ubuntu 1 system outside of our script. So we then think, well, really, is there any difference other than me actually typing more information when I run apt-get? Well, let's take a look. If I go through and run SSH, so if we go SSH to our 192.168.56.102 system, and then run the command sudo apt update. So this is what we should be using interactively at the console. When we do it remotely, we're not going to have a terminal assigned to us, so it's going to throw a little bit of wobbly. It's probably going to work, but advises me against the use of it. So as I connect in, I've got to accept the public key from the remote system. The vagrant user's password is lowercase vagrant. And we get that warning, app does not have a stable CLI interface, use caution within scripts. Now, no, it's not within a script, but it's the idea of not having a terminal associated with the apt command. Whereas if I clear my screen and then go and run it with apt-get, this is designed then for your scripts or remote execution usage. Again, I've got to go through and authenticate. But we can see now that it runs without that complaint. So do consider this when we're running it non-interactively to use apt-get, where we can make do just with the apt command, making use of our local system. So hopefully that gives you a good idea of the differences and is clear within your mind. Obviously, in a practical exam, it doesn't really matter which one that you use, so long as it works okay in your environment. Now, as we mentioned before, we have this package cache. The package cache is just metadata about packages that are available in our apt repositories online. If we go through and do a long listing, we're going to be able to see the last modified time of then our cache file. So var cache apt pkgcache.bin. Now that gives us an idea of when it was last updated. If it's been updated recently, which is a very vague term, I know, but if we've updated it, let's say in the morning, there's probably no real need to update it again by the afternoon. But we might find if we try and install packages, we get package not found, as the updated online file is now newer than the cache represents. We can do an apt update. And an apt update is always a good idea at the start of an install, so we have got up-to-date information before we try and install our software. But say if we've recently updated it, there's no real need to go through and do the update again. Once we have updated it, if we go through and do a long listing of the same file again, we'll see the last modified time has changed, indicating when we last updated. So it's a simple way you can decide whether or not we actually need to, and perhaps you could programmatically build this into scripts so you don't unnecessarily go through and do the update or updating your package cache unnecessarily. When we look at the apt list command, the apt list command will list every single package that's available in the repositories. This will include those that are installed. We can go through and filter, so we can look at those that begin with ZZ, or we can look for an individual package. But we're also able to go through and get a list of those that are installed, those that are, let's say, upgradable. Upgradable is different to update. Update is updating the metadata. Upgrading is taking an existing package that is installed and upgrading it to the latest version that's in your repository. If we want to look at information about a package before we install it, we could use apt show. Apt show will show the metadata, and again, the metadata is stored locally as part of our cache. If we don't know exactly the package we want to work with, we can work with apt and the search subcommand. So apt space search Apache. But this then is looking for the string Apache anywhere in the name or description of the metadata. We could drill down, so we're only searching inside of the name, but we're still searching for the string Apache anywhere within the name. We could also build in, though, regular expressions. If we use our regular expression, generally we're going to quote it to make sure that the bash shell doesn't do anything with the meta characters. We want them passed through to app search so it can be treated as a regular expression. And where we use the caret or the uppercase 6 on a US keyboard, we're looking for lines beginning with. So we're now only going to be listing those packages that begin with Apache. And again, I think we've looked enough at these slides, and we've got to get used to these commands and being able to use these commands as a matter of course. So why don't you join me at the command line for our learning experience? And yes, we're going to dive out to our command line, and we're going to be working with our apt cache. Remember, this holds the metadata about the packages that are available online. So we're taking a look at the apt update command and when it was last updated. We can look at listing packages. We can look at upgrading. So remember, upgrading is different to our update. Update is updating the metadata. Upgrade is upgrading installed packages. And we can read package metadata to give us information about packages that are available. So come on, let's find the command line. And here we are back at our command line. If I go through and run the ls and -l command, we can get a long listing. A long listing is going to include the last modified timestamp. And if we go through and take a look at /var for variable data, cache, because of cache data, and then apt for apt, and look at then pkg cache.bin. This is our online package cache that gives me a representation of the packages that are available through my repositories. But it means I can search the file locally rather than having to go through and search the online repositories. Now, when we take a look at this, it was updated at 0927 today. So it probably doesn't need to be updated, but we are going to do the update. We can go through and use our sudo. We have to elevate our privileges for this. And we can use apt update. But we could also, if we wanted to build it into a script, use our apt-get and update. And update. Either is going to work, but remember we're using apt-get where we're running it in scripts. So we go through and connect to the repositories, and we can see the repositories that we've got configured on this system. Additionally, I've got a third-party Ubuntu repository that we can see that's been added in. So yours might look slightly different to mine. But with this done and dusted, if we go back and just take a look at the long listing of our bin file again, we can see then the update time has changed from 927 to 958. Now, say we really only need to update our cache if it's not recent. So obviously, when we're just looking at 30 minutes ago, there was no real need to run the update. But in general, if we then log on to a system, we probably want to be doing the update before we start working with any of our packages. But we can also then go through and use our apt and list subcommand. We can also use tab completion so we can see what's available to us. So I can then tap apt list or li and tab complete. But if I go back and just look at apt and then double tab, the double tab is going to give me a list of subcommands that are available to me at this level. So we can use apt and list. And if I just run apt list, it's going to go on almost forever as we list every single package, whether it's installed or whether it's available. So this is looking at the complete metadata, the list of packages that are available in my metadata at the moment. we can drill down a little bit. So let's go through and just clear the screen. And if I do then, let's say ZZ and asterisk, the asterisk is our wildcard here, and it's going to expand to anything that starts with ZZ, whether we have characters following it or not. And we then get a couple of packages that are showing here. If I look at one individual package, we can do our ZZUF, and we can see then just that package. So we're able to drill down to what we want to be able to see. But we could also go through and list minus installed. So we can only look at the installed packages. Now again, we're still going to have quite a few installed. And don't forget these little tricks, especially if you're new to Linux. If we want to count the number of installed packages, we can do a word count minus L, the number of lines. Now this then again comes up and saying that we don't have a stable interface because we're piping the output. But it gives us the idea of some of the things that we can do. But look, 603 lines here. So 603 packages installed. If we want to look at the upgradable, so those that can be upgraded, we currently see there are no packages that are currently installed that have a later version online. But this then gives me an idea of anything that we could update. So at the moment, it looks like we are up to date and there is no need to go through and upgrade any of my packages. But if we wanted to upgrade our packages, it would be running something like this, where we would go through and run upgrade and then the package name. So let's say Ansible. I have Ansible installed. Now again, with this, I've forgotten to do the sudo. So it's very easy then to do a sudo bang bang. And we can see here that we're already at the latest version, so there's no need. But kind of we could have guessed that, as it was telling me there was no packages that were needed to be upgraded. Again, I can clear the screen. And we're just about ready now to move on to our next clip. In our next clip, we get a better idea of how we can search the metadata if we don't know the name of the package that we are looking for. Now, if we're working on our system and we're not quite certain of the absolute package name, we can search our metadata. So we can go through and look at how we can search and locate information about our packages. So let's move out to our command line. And from our command line, we can go through and maybe look for our packages that we're looking for. Now, we might be looking for the Apache web server, something like that. We can go through and use then our apt. We don't need to elevate our privileges here. And then search. We can go through and just look for Apache. But we're looking for the string Apache, and that could be anywhere within the metadata, be it the name or the short or long description. So with this, we're getting, well, yeah, a lot of results coming back. If we wanted to run it as our non-interactive, it would be apt cache with this one. So apt cache and then search and then Apache. But again, it's going to give me the same basic idea, but you can see we don't get the color coding this time. If we wanted to go through and just look at the number of results coming back, when I go through and take a look at this, we can pipe it through to word count minus L. And we can see, look, there's 609 results coming back with the string Apache. Well, again, we can go through and then search a --names -only and then Apache. Now with this, we're probably not seeing too much difference, but if I go through and count them with word count -L, we're down to 154, so 609 down to 154. So we've already got much better. But we can also go through and thinking, well, if it's the Apache web server, it probably starts with Apache, so we can put then regular expressions. We're going to put single quotes around our string. Now, that in itself is not going to make any difference, but if we start including meta characters, such as the caret, the uppercase 6 on a US keyboard, this is specifying that the lines begin with. But we want to make sure that these meta characters aren't going to be interpreted by the bash shell, so they're passed through to apt or apt cache in this case. Remember, we're using apt cache just to get to look at some of the differences we can look for. Now with this, we can see that we're getting just 12 results coming back. And this is probably more positive when we take a look at the output. So we can see there we've got the Apache 2 package is probably what we're looking at. But if we want to make sure that is the correct package, what we could do then is apt and show Apache 2. So we're able to go through and take a look at the metadata relating to that package. And we can see then when we look at the information, moving down to the description, the Apache HTTP server project's goal is to build secure, efficient. So yes, we can see this is going to be our web server. If I clear the screen, so Control and L, we're back then to a clear and empty screen. And we can remind ourselves that we've been able to take a look at a few things here. We've looked at the apt list command to be able to list packages that are available and ways that we can drill down with things like --" installed and --" upgradable. We've also seen how we can use then our apt show and go through and then start searching for package names. Drilling down on that, we can use --" names only, so we're searching the name rather than the whole metadata. Now let's return back to our slides so we can look more at managing our packages. Now when we're looking at managing software, I suppose the real big things is installing software and perhaps even removing software. So that's what we're going to take a look at now. Here we can go through and look at apt install or apt-get install. The option -y is there so we automatically accept that the software is going to be installed. Otherwise, it's going to prompt for us to install the software. The software that we're installing here is a single package, Postfix. It's an email server. But we could have a list, just a space-separated list of packages if we wanted to install more than one. Removing software, we can use either the remove or the purge subcommands. And again, it still would be apt-get if we were removing software. Remove removes the software packages but doesn't change the configuration, leaves the configuration there, whereas purge will remove both the software and purge its configuration files. When installing software, very often we're going to be adding in dependency packages, and that's one of the great things about using apt. It's not just installing the one package, the package that we say, it's going to install dependency packages. But when we remove the software, the dependency packages are not automatically removed, and we have to then configure it or remove it with apt and auto remove. Again, -y is just going to remove all of the packages that need to be removed. Using auto remove, we can do it immediately after we've removed the software. We might also decide to schedule it maybe once a month or something like that to make sure that we're regularly going through removing software that's been added that we no longer require. During the installation of some services, there may be a configuration script that runs, and we're going to be prompted with certain questions. We can change the triviality of the questions that are going to be asked with the Debian_priority environment variable. If we set it to low, we're going to get the most trivial of questions. I wouldn't look at this as a negative thing, but it means that we can do more configuration during the installation of the software because we get more questions that are being asked. Our normal questions are going to be at the medium level, whereas we set it to high, we're only going to be asking questions that don't have reasonable defaults. At the least amount of questions that we can ask, it would be critical. And these then only include questions that must have an answer. We can see how we could use this by either setting the variable in the normal way with, let's say, export, variable, and value. But if we just need it for one installation, we can include it in the command line. So here's sudo and Debian priority equals low. apt install -y postfix. We had something like 2 questions being asked before, but we can get more questions being asked now because we've set to low priority, so we will get more questions. Now, to really understand this, I'm going to encourage you to join me in the demonstration. It's the demonstrations where we actually get to do some hands-on, and that's where you're really going to start learning. So we're going to be working with our software installation, looking at installing software, removing software, and working with those variables. So come on, let's find the command line. And here we are at the glorious command line, and we can begin straight away by doing a sudo apt install -y just means that we're not going to be prompted to install the software. And then we can go through and put the package that we want to install. This can be a single package, such as here, the email package postfix, or we can put a list. Now, we can see this has got a script during the installation. We don't need to worry too much about what we're setting here, so I'm going to be accepting the default. But we're also going to be able to demonstrate how we can get more questions when we change the priority of our Debian_priority variable. The idea of the configuration means that we can then start the service once the installation is complete. And we're able to quickly check that by taking a look at our services. So sudo and systemctl, we'll see more of this in a later module, but taking a look at the status of our service, which is also called postfix. And we can see that it's enabled, so it's started, and it's currently running, and we see information from the log. Again, Control and L will clear out my screen. If we go through and remove the software, we can either use apt and remove. Now that's going to leave our configuration files. But if we want to remove the configuration files as well, we would use purge. The idea is we might want to install it later. If we've made configuration changes, we might as well use the same configuration as we used last time if we use remove. Whereas purge, remember, we are getting rid of the configuration files as well. So with that done, obviously we've removed it, but looking carefully at the screen, we can see that one of the dependency packages, it was added but not removed. To remove it, we can see the command sudo apt auto remove, and we can go ahead and of course remove it. Now we can do this immediately now, but also I would probably want to schedule this maybe to happen once a month or something like that, just to cover those instances where we've forgotten to run the auto remove command. Now we want to take a little bit of time now looking at the environment variable Debian_priority. We've seen the default questions, but we can configure more if we change the priority variable. It's really an environment variable. We can set it in our normal way with the export command, But we can additionally go through and set it so it only is effective for this one instance of the command. So sudo Debian_priority, and we can set it to equal low so we can get the most amount of questions. This allows the greatest amount of configuration during the installation. So don't think as low as being negative in this instance either. Apt install -y and then postfix. So other than setting the variable, the command is exactly the same as it was before. But take a look at the amount of questions that we're now going to see. As I hit the big enter key, we start our installation and we see the same question before. We're again leaving it all at the defaults here. The system mail name, but now we've got additional questions, so the root and postmaster setting up aliases. The next question is just saying a list of destinations that we can accept mail for. We can go through and we don't need to force a synchronous update. We can specify the local networks that we trust. Again, I'm just accepting all of the defaults here. And then as we progress through, we can see now that we've got the mailbox size limit. We'll leave this at no limit, 0. The local address extension, so those addresses that are recognized as being local to our system. And we can then specify we want to listen on both IP version 4 and IP version 6, or if we wanted to, we could go through and change this if we needed. Let's say we only needed to worry about IP version 4, then configure to listen only on IP version 4. We can click then OK, and then we're going to continue with our installation. But now we've been able to configure more options during the installation by just knowing a little bit about that Debian_priority environment variable. But with that set, we've got it configured with a little bit more now, and it's more configured the way that we need. Now let's return back to our slides so we might look a little bit more about our repositories on the internet. Now, one of the great advantages of working with something like the apt or the apt-get command is that we're able to query software from online repositories. So we'll install both the package and all of the dependencies that we need. The location and the properties relating to our repositories are stored in the file /etc/apt and sources.list. There is also an extension directory, etc apt sources.list.d, and we could expect to find .list files inside of that directory. If we use sudo apt and edit sources, it's going to open up in our editor and open up our etc apt and sources.list file. We can use that just to display. We don't need to actually edit anything if we don't need to. Having looked at our file, we can also then go through and look at our apt keys. Apt key list is going to list the keys, and these are GPG or signing keys that we have available. The idea of a key is that packages are signed, so we know then that they've been delivered without having been tampered with after they've been added to the repository. We can download a key. So if we want to add in another repository, maybe the first step is to download the signing key. So we can use wget to retrieve that. Here we're saying our output file is going to be standard output, so -o-. We're going through to a third-party site, aptreleases.hashicorp.com. HashiCorp make products like HashiCorp Vault and Terraform. We can send the output of wget straight through to our apt key and add. Again, the dash at the end is just saying we're reading in, this time from standard input. Having added in then our signing key, we can add in our repository. So the add apt repository command. And we can then go through and specify that it's a Debian repository rather than a source repository. We can specify the address. And at the end, we have focal being our version or product that we're working with, and then the main repository inside of focal, inside of HashiCorp. Adding the repository will add it to our sources file, but again, we can go through and see our sources file with apt edit-sources. Now, of course, we didn't really need to use the apt repository command. We could have actually just written that information directly into our sources, but it is there if we wanted to make use of it. So this is what we're going to be taking a look at now. We're going to move back to our command line to look at managing repositories. We're going to be adding in that GPG or the signing key. So we're going to download that and add it in as an apt key, and then adding in a third-party repository. So working out our glorious command line, we're going to go through and use the command sudo to elevate our privileges. And we can then go through and use the apt and edit-sources. Don't forget we've got tab completion, so I don't need to write anywhere near all of the subcommand out. Now this is going to open up for me the /etc/apt/sources.list file. So if I hit enter, the first thing it's going to prompt me is which editor do I want to use. I'm going to stick with Nano. It's not going to be a particularly large file, so Nano is going to be okay. The default is in the square brackets being 1, and I can then hit enter. This is just the first time that we go through and run the command. Now it's highly commented, but we can see from the top of our screen that we've opened up the file /etc/apt/sources.list. The uncommented lines show the repositories that we're currently working with. I'm just going to go Control and X to jump out. And the next command we're going to look at is apt-key. If we go through and run the list subcommand, we're going to list the signing keys that we've got. And these are going to be fairly standard. And when we take a look at these are really the Ansible Ubuntu, the Ubuntu key rings, the Ubuntu key rings from the archive, the CD image, and then the 2018 archive. Again, I'm going to clear out. To download a key, we can use wget. We can specify our output, so -O for specifying the output. And we can have our output file being written to our standard output. We can specify that we want to go to HTTPS, and then we're going to apt.releases.hashicorp.com. So that's our server, and we can go through and then bring down the GPG key. These keys are used for signing in this case. If the package has been signed, we can verify that it's authentic and hasn't been modified since the author added it. We're going to pipe the output of this through to our sudo and apt key. We used apt key before, but with we're reading information, we didn't need to elevate our privileges. But where we're adding the key, we need to elevate our privileges. And the key we're adding to is going to come from our standard input. So we've downloaded the key. We've now added our key. We're going to add in our repository now. I'm going to use Control and L to clear the screen. And then sudo add-apt repository. Again, tab completion helping me there. We know I can't type that quickly. And then really the line that we're going to add in. So it's a Debian. We can have Debian or source repositories, SRC. We can then go through and specify the address at HTTPS. So it's going to be similar to where we were looking at before. So where we got the key from, so apt.releases.hashicorp.com. And then our product, which is going to be Focal. We're on Ubuntu 20.04. And then the main repository. If we hit enter on that, we both download or add the repository to our sources.list, but we also then download the metadata. So we've done an apt update. If we go back now and take a look at our apt key list, we can see that we've added in a key just at the top there, our HashiCorp security package signing key. And as we go back up and look at our edit sources, this will be towards the end of the file, but as we then arrow down, we should be able to see the entry that we've added in. And I say we could quite easily have typed this in ourselves. So as we run our way down, we've got our deb https @releases.hashicorp, focal, and main. If I go through and save these changes now, remember I don't need to, I'm just going to exit out. We haven't made any changes. But when we go through and do a sudo and apt update now, not that we need to, we saw it was updated when I added the repository. But we can see then it's just added to the list of repositories that we are updating from. So hopefully that gives you a bit of an idea of what sits behind our sources.list and where we get our software information from and how we add in third-party repositories. Now, at the very heart or the foundation of our software management within Debian-based systems, we have the dpkg command. Now, we don't generally need to use it, but it can still be very useful to be able to go through and find out information about what we've got installed. dpkg-l is going to list all of the packages that we have. Using uppercase L, we can go through and look at the contents of a package. So if we've installed a package and we want to know what files have been added, we can go through and use the uppercase L against the package name. We can also go through and investigate a file within our file system and show the owning package. Another useful option is the dpkg reconfigure. If we've forgotten perhaps to change the Debian priority and we want to look at reconfiguring a package, we can reconfigure it and it's going to show the most verbose questioning that's available. So if we use a dpkg reconfigure, irrelevant of how it was installed, we're going to be seeing the most trivial of questions being answered. It's a great way to very simply go through and reconfigure a package without having to know the ins and outs of the configuration file. We're going to be able to see some of this by moving out through to our command line now and working with the Debian packager itself. We can look at the dpkg command, the dpkg reconfigure. So come on, let's go through and find that command line. Now this looks like a command line to me, and the very first thing we might want to do is try running our dpkg command with the option -l. Now with this then we can see the status of all of our packages. So we're able to see those that are installed and perhaps some that have problems. Everything is just shown with the eye for install at the moment, so this is looking pretty good. But I can then just use Q to jump out of this. If I go through and use Control and L, we can move back to the top of the screen. We want to interrogate a package. Let's say that we've added in the postfix package. So if we want to go through and look at what that actually added in, we can go through and look at the package using the uppercase L And then we can see everything that was added in by the package. So we can see then all of the programs, the USR bin files. We can see all of the documentation files. And we can see we've got man 1, man 5, and man 8. Documentation underneath the USR share. And then supervisory commands underneath the USR sbin. Okay, I'm just going to jump straight out of this. We could also go through and interrogate a file within the file system. So for example, if I went and let's say just go through randomly, look at something in the etc directory. If I wanted to see what put in the fuse.conf, I can clear out my screen. And I can go through and use a dpkg minus uppercase S and then /etc/fuse.conf. And we look at that, that actually comes from the package fuse. Now we've also seen that by using our variables, we're able to control the questions. But we can also go back and rerun those scripts. And we can always have the most trivial, the most questions being asked. So with this, if we go through and run our sudo dpkg-reconfigure and then postfix, irrelevant of how it was last installed, we see then the most amount of questions that we can be asked. And of course, we can change any of that configuration if we want to, and it's going to reconfigure it, and we'll just need to go through and restart our service. So here we were listening on IP version 4. If we want to go now and listen on all interfaces, so IP version 4 and IP version 6, we can change it. So we've been able to go through and make those changes, but then as it reminds us, we should go through and make sure the service is restarted. So we can go through and reload our postfix service. And we should be listening now, and we should be able to see this both on IP version 4 and IP version 6. And if I go through and look at my SS-NTL, now, port 25 is a port that we're looking at, our mail port, and we can see then 0.0.0.0 is IP version 4 and all interfaces. Moving down, we can see that 25 is also listed against : and that's all IP version 6 interfaces. So we can see it's listening on both IP version 4 and IP version 6 and taken on the new configuration that we've made. So we should be a little bit more convergent now with our management system of software within our Debian-based systems. But let's make sure we take a little bit of time to recount what we've looked at in this section. And look at this, the orange sunset, another module that you really need to congratulate yourself on reaching the end. We've been all about managing software in this module. So looking at the apt and the apt-get command, but don't forget, we can get away with using apt, and it's going to work better because it can give us color output and multiple lines, but it's not so reliable if we're running from scripts. So we use apt-get when running in scripts or running remotely, as we saw with the remote SSH commands. We can use apt-get update or apt update to update our package cache. The package cache file itself is pkg-cache.bin inside of var cache and apt. If that's up to date, then we've got great metadata relating to the packages that are available in our online repositories. But if it's old, then it might be pointing to files that no longer exist because we've got newer versions available from them. So we need to make sure that it's kept up to date. A long listing of this file will show you when it was last updated. We can go through and list our packages with apt and list, but we can also go through and search for packages by using apt and search. apt and show will show us information about our packages. Using apt install, we can install packages, and then we can either use purge or remove to remove our packages. With remove, we might leave configuration files there, whereas purge, we're also going to remove the configuration files. Playing around with our environment variables, we're able to make sure that software that have scripts that will prompt for questions, we can be asked the most amount of questions available in the script by setting our Debian priority to low. When adding third-party repositories, we're probably going to need to download a GPG signing key, as well as then adding our repository to our etc apt and sources.list file. But we have commands for that, so we've got our apt key and our add apt repository commands. Now, even though the concentration has been on the apt commands, the toolset that sit above dpkg, we can still use the native commands. We're unlikely to use it for installing software because we're going to have to put in a full path name to install a .deb file, and we need to install the dependency packages before we install any packages that require them. So it becomes a little bit more cumbersome. But we can see by using things like the uppercase L, we're able to list the contents of a package, and we can query a file with the uppercase S to show the owning package, as well as being able to rerun our configuration scripts with a dpkg reconfigure command. So still very relevant and very important. Now, we might have finished this module, but we're not finished by yet. We've got a long way to go, and we're going to be taking a look at managing our systemd based services and targets in our next module. Hello and a big warm welcome to this Pluralsight presentation. My name is Andrew Mallard, and I'm here as your instructor to help guide you through the module managing systemd services and targets. Now, of course, this is a module where we're going to be looking at how we manage our systemd-based Linux systems, which is going to include the latest versions of Ubuntu, Red Hat, and many other Linux distributions. The big thing that we get with systemd is uniformity. So we can use the same commands across many different Linux distributions, irrespective of where they need to write to. We're going to be able to use the one command no matter which distribution we are using. We have an ecosystem that sits behind systemd. So of course we can manage our services with systemctl, but we have other commands that we can use, such as setting the host name or configuring the time and date or configuring the locale. One of the main things with systemd, though, is our system and service manager. So we'll be taking a look at managing our services. But along with services, these can be grouped together in what's called targets. With this, we can enable a service to auto-start within a given target. The final thing that we look at are logs. Now, we don't have to use our ecosystem to be able to look at logs, but we also have the journalctl command. So we get in the pattern of all of these commands ending in ctl, mean that they're probably fitting into our systemd ecosystem. But using journalctl, we're able then, again, irrespective of our distribution, to be able to query our logs based on a certain amount of filters we want to put in. Now, when we take a look at our ecosystem, we can set our host name. This can set then our host name both statically, so persistently in the backend file, irrelevant of the file name, as well as transiently, so in memory for the current session. We can use timedatectl, and this becomes an easy way, irrespective of your system, to be able to set, let's say, the time zone or configure time synchronization. Using the localctl, we can then go through and set our language and character set we want to use. Systemd in this infrastructure, the ecosystem around it, has been around in Ubuntu since 1604, so 2016. It started out in about 2010, the Systemd project, but now when we look at 2022, we can see that we're at a stage where it's got a lot of maturity behind it. We can move out now to our lab system working on Ubuntu One, just to take a look at how some of these commands work. So yes, we're going to dive through to the command line of our Ubuntu One system. Using the Ubuntu One system, we can go through and investigate this idea of Linux uniformity. We're going to be taking a look at the hostnamectl command. We'll be looking at the timedatectl command and the localctl command. These are just a few of the commands that make up the ecosystem that sit behind Systemd. So come on, why don't you join me at the command line? And look at this, the glorious command line that sits behind our Ubuntu One system, where we can investigate the ecosystem that props up our Systemd Linux distributions. The first thing, we've probably already seen this before, is the hostnamectl command. We're able to print out both the hostname, but perhaps more importantly, things like the operating system. So if you've just logged onto a system and you don't really know the distribution that sits behind it, we're able to see this. Here we're using Ubuntu, but could quite easily be Red Hat or CentOS or Arch Linux. We can also see the virtualization that is in use. Here it shows us Oracle because we're using Oracle VirtualBox. So it's the consistency that we're getting across any Linux distribution. As a standard user, we're able to print out the information with hostnamectl, but it goes way beyond this. We're able to configure information too. So using sudo to elevate our privileges, we're able to then run our hostnamectl command, and we can go through and set our hostname. So currently it's set to Ubuntu One, but if I want to, I could set it maybe to the hostname of main, being our main system. Now, it might look to you that it hasn't changed because, of course, our prompt hasn't changed. That was set when we opened up the shell. But if we investigate what's behind our system, so looking at hostnamectl, we can see that the static hostname has been configured to main, irrespective of where that was stored. We can also use the hostname command and look at the transient, the memory resident name, and we can see that is also set to main. Now, on an Ubuntu system, the host name is configured in the etc and host name file, and we can see then that that has been configured to main. But it's irrelevant of where the storage was. Our local Systemd management ensures that we're writing through to the right file. So it's the consistency, the one command that fits all of our Linux distribution. We can also use the timedatectl command. Again, as a standard user, we're able to print the information. Well, we can then go through and start seeing, well, what the current date and time is, but also things like our time zone and whether we're synchronized with the network. Now, this being a cloud-based system in the fact that it's a virtual machine that's been delivered from the cloud, we don't know where we would be using this. So our time zone has been configured for just UTC, not any particular time zone. We're also not synchronizing our time service, which we could set up from here as well. But if we look at just setting the time zone, and looking at the consistency that we would have on all of our Linux distributions, it's very easy for us to elevate our privileges and run timedatectl. And we even get tab completion on our subcommand. So if I go set time and then tab, I get to see time or time zone. Obviously, I want to set the time zone. And we can go through and configure it again using tab completion. So I can hit E and tab complete on Europe, and then choose the city. Now, I know I wanted London, but if we didn't know the city we wanted, we could see all of the time zone cities within Europe or America or Africa, whichever continent we were using. So I can hit the big enter key on that. And of course, now we've configured our time zone. That will be configured on Ubuntu with the symbolic link etc local time that is now pointing through to the correct time zone file. And again, we can just see the ease at which we can configure this. But of course, it doesn't stop just here. We saw from the slides that we had another command. There are many commands that we can run, but let's take a look at localctl. So we can see then the locale setting. We can got then our UTF-8 character set, but it's been set for our language to be C. So really just a very standard compliant version rather than anything specific to a country. If I needed to set the correct language locale, then again I elevate my privileges, use the localctl command, and then set locale, and then lang equals, this is just a variable we're configuring now, and then en_GB, and then .utf8. Now again, that's then configured correctly. I can go back and view it with localctl, and again, other elements I could set should we need. But we've got this consistency now between all of our Linux distributions. So long as they're using systemd, we're able to go through and configure elements, and something that's really been long needed within Linux just to make it that more accessible. When we talk about systemd-based system, we're really talking about process ID 1, the first process that is started after our Linux boot. So we have our bootloader. We know that the bootloader is going to load and choose a selection from the menu. From a menu, we're going to be choosing then a kernel and a RAM disk. Once the kernel, though, has started, the kernel will be initializing process ID 1 systemd, and this is our system and service manager. Another really good feature that's available with systemd is that we're able to analyze the boot time. So very simply, we can go through and use systemd-analyze. With this, we're going to see how long it took to load the kernel, load the RAM disk, and then our services. If we need to decide which service was taking the longest, we can go through and add in the option blame. Now, I don't really like the term blame here because we're not really blaming any particular service, but we really get a very brilliant printout showing me the services from the longest starting to the shortest starting service, so we know where we can start tuning our boot time. Now, to really be able to understand this, though, I'm going to encourage you to join me at the command line of our Ubuntu One system, where we can go through and analyze our system startup, looking at what we mean by process ID 1, and then analyzing the boot process. And look at this, a glorious command line if ever there is one. Correct me if I'm wrong, but isn't this just wonderful? And it's going to be even more wonderful when we start taking on board all that there is to know about systemd. Now, the first thing we're going to take a look at is using the pstree command. With pstree, we see our process tree. And at the top of the tree, we have systemd. Systemd is our system and service manager, and it starts up all of our other services and manages our process tree in itself. It will be process ID 1 sitting at the very top, and is going to be started by the boot process and the loading of our kernel. To interrogate a little bit more, we're going to be able to use the ps command, our process status command, taking a look at process ID 1 minus P1, and then adding in a full listing. Now, when we take a look at this, we can see that it's a user ID root. It's owned by root. It is process ID 1. It does show us having a parent process ID, and that parent process ID shows us 0, but that really is our kernel, the kernel scheduler. Now, when we take a look at the command, it shows /sbin/init. And when we might think, well, this is a little bit strange, I thought we were meant to be looking at systemd. Sbin and init are supervisory binaries, and init is the old system and startup manager. But we know we can take a little bit more of a look at that process, or the init command. So running an ls-l, a long listing, on /sbin/init, we can see that the hiding behind that, we have systemd. Init is just a symbolic link through to systemd. So process ID 1 is really systemd, but it's being run through the symbolic link /sbin/init. So hopefully that's making a little bit more sense to you. But we're also here to show some of the great reasons why we have systemd-based Linux distributions. And one of the really brilliant things that we're able to do is take a look at systemd and analyze and our boot process. Now we can see that the kernel itself took 3 seconds, more or less, 2.867 to load that. Our user space, so our services that load after that, 9.9 seconds. So that's looking like something like 12.815 seconds, our boot process. So it really didn't take too long. When we can see, though, the graphical target, and the target is when we were then presented with a login screen, then that's 9.4 seconds of user space. So we can get an idea of how quickly we presented a system to the user. Now, it might be a desktop system or it might be a server system, but either way, we can see when they were presented. Taking a look a little bit further, we're able to use the blame subcommand. With the blame subcommand, it lists our services and the time each one of those services took to start, starting with the longest service and then moving down through the page less. We're able to see all of the other services going to the ones that were most quick. Now, the services in systemd can start in parallel. So even if we were able, let's say, to completely get rid of, let's say, the snapd service, the .cd service, we're not going to improve the boot process by 2 seconds. Other services will be starting whilst that's starting, but at least we can go through and start seeing the services that are going to benefit greatest from being tuned to give us the fastest startup. So hopefully you've seen some really fantastic stuff here, and you can use it on your own systems to gain an idea of what's taking a long time during the boot process. Now, we've already had a good look at the systemd ecosystem and a whole heap of commands such as hostnamectl that end in ctl. But I suppose the biggest amongst those in the ecosystem is systemctl, used to manage our services. When we take a look at using systemctl, one of the things that we can look at is the status subcommand, and looking at the status of one or more services. We're not limited to one service here, although we've just got the cron service that we're showing here. The cron service is there to schedule tasks. Now, the status command isn't just going to show that the service is running. We're going to be able to see if it's enabled for auto start, as well as the process IDs associated with the service, and importantly, the latest log entries. Now, we can run systemctl status as a standard user, but to see all of the log entries, we might still want to run it as a root user, where we show in these slides the hash prompt rather than the dollar prompt. We're indicating we are running as root. We can enable our service. Enabling just means that when the system starts, the service will start. But if we only enable the service, it's not going to start the service there and then. So a really popular option is to use the option --now. If we use enable minus minus now, it will both start the service as well as enabling it. In the same way as we use disable, disable on its own will only disable the service, so it's not going to auto start. But using the option minus minus now means that the service is also going to be stopped. So it saves me having to do an enable and start, a disable and stop. We can do it in the one command by incorporating minus minus now. If we want to look at the definition of a service unit, we can go through and use the cat subcommand. But it doesn't stop there. We can also go through and edit. So this will open up the file for editing, and we can make a full copy rather than just appending to what was there. So really, really useful elements have been put in for us. But there is more, and we're not going to put them all in the slides because it's probably better just to get some good hands-on. So I really encourage you now to come out to your command line, enjoy your finger exercises that we're going to do, as well as the mental exercises where we commit some of this to our mental memory. Come on, let's get exercising. And yes, we're going to spend some wonderful time at the command line where we can take a look at managing our services using the systemctl command. Now, there are many options that we're going to be taking a look at as we go through. We've listed a few of them here, but the best thing is to be able to get into our command line and really start using this command. So come on, join me, and we're going to have some great learning experiences. And here we are on our wonderful Ubuntu One system, waiting to begin learning about systemctl. Now we can go through and run our commands, some of which are standard users. So systemctl, and let's say status, and we can go through and look at our cron service. So if we go through and put cron, this will work. The default unit type is service. So if we don't put the unit type, and what I mean by that is putting .service at the end, as I add that in, then we don't see anything different, but we default to looking at service units. There are other type of unit files, such as timers, such as mounts, such as, and we'll look at these later, targets. Now, we can look at it with the eyes of a standard user, but we can see that we have insufficient permissions to be able to open up our logs. So even though we can look at it as a standard user, we might prefer to gain root access. I'm going to use a sudo -i so we get a main shell running as our root user. So we don't need to worry about then the sudo command in front of systemctl. We can see that we get the hash prompt. The hash prompt is a good indication that we need to be running as root, if you see that in the slides. So if I look then at status, and again using the cron service, we can see now that not only do I get the status information that we saw before, but we get then information relating to our log files. So really good summary of what's going on. One of the things when we look at our service is that we can see the service is enabled. By enabled, we mean that it will start when the system boots. Active means that it is currently running. If I go through and clear my screen, and if I go through and disable the service, disabling the service by itself is not going to stop our service, but we're just meaning that it won't auto start. So as I go back and take a look at the status, we can see we've got that green light showing that we are running, and we can see that it is disabled. So it's not going to auto start. If I want to stop the service, then I can clear the screen, up arrow key, and then we can go through and use stop cron. Now, if I go back up, we can see now that I'm not getting the green information. And because the process isn't running, we're not getting any of that process information. And we can see then that it is inactive or dead. Now, as we saw within the slides, I can enable the service. So we can use the keyword enable, and I can use -- now. If I hit the enter key now, we're both going to enable the service and start the service. And the same way, I could use it with the disable and now, and it's going to make sure that it's both stopped, but crucially going to be disabled as well. Looking at my status, we can see then that it's all up and running, and we're seeing that it is enabled as well. So really good shortcuts. Notice with the active as well, we can see that it's been active for, in our case, 12 seconds, but we can also see how long the service has been running for. If for whatever reason I don't want a service to start, I can go through and mask the service. So if I choose then mask -- now, so that's going to stop our service as well. When I go through and take a look at the status, we can see then that it's dead, and we can see it was 4 seconds ago, so we stopped the service. And we can see that the service is marked as masked. And what we mean by masked is that the service unit file is pointing to /dev/null. If I try and start the service, whether I'm doing that myself or whether it's being started automatically, we can see that it fails to start. So we're putting on a little bit of a safety lever here, preventing accidental start of a service. If we need to unmask our service, we can then go through and unmask. And again, I can use -- now. Now, as I go through and take a look at the status now, it hasn't started it. It is enabled for auto start, but I have to manually go through. Let's clear the screen and start the service. So masking can be really good. Well, we don't want to remove the service, but for whatever reason, we don't want the service to start without some administrative effort. If we want to look at our service, we can go through and use the cat command. So I don't have to know where the service is, but we're now listing the service, and we can see that we're reading it from /lib/systemd/system and cron.service. If I needed to edit the service, there's nothing really I want to change, but maybe there were some of the options that I needed to change. One of the things that we could do for that then is to go through and clear our screen and change the cat to be edit. If I edit it, it was going to create an override file, and anything that I put in there is going to be overwriting anything that's in the normal file. Sometimes it's easier to do a full edit where we create a completely new file based on the old file. The file that we create becomes then our version of it. Instead of being in USR lib systemd, it goes into etc systemd. Let's go through and change our description. Regular background program processing daemon. We might want to then go through and put, let's say, something more readable. And then, job scheduler for regular tasks. I've got a scheduler spelled wrong. It doesn't really matter, does it? But we might as well go through and tidy this up. If I then go through and save this, so Control and X, and yes to save, enter on this, that now becomes our file to use. If we wanted to be double checked, we could reload our configuration, so System D, and then our daemon reload. So that just rereads our configuration. And now our system CTL and status on cron. We can see now the job scheduler for regular tasks. We've got our description, and it became an easy way both to be able to see the contents of the file using the catsum command, but also to easily be able to edit it. So this gives us an idea of some of the things that we can do to manage our services using the systemctl command. It's like anything, get good practice with it and make sure you are really familiar with it when you face the exam. Now let's build up a little bit of a scenario. Let's say that we want to create ourselves a disk file that we can use as a storage device inside of Linux. To do this, we can gain our administrative privileges, and we can use fallocate to create the underlying disk file. To make it usable as a storage device, we can use losetup to create a device file. Here we're creating the loop10 device file from disk 1. We can go through and then partition this. So we're adding a partition table and creating a single partition on it. Listing our block devices, we're able then to see that we've got then both our device file and the partition on the device file. But if I reboot it, even though the disk 1 file is going to persist, on a reboot, we're not going to get the device files. We would need to go through and link the disk file to the loopback device, and we would need to read the partitions using part probe. We can use a service unit to be able to do this. Because I say the problem is that the loop device we have does not persist. The backend file does, but not the loop device. So creating a service unit, we can automate on our system boot the creation of our loop device and read in the partition table with part probe. And that's what we're going to be taking a look at. When we take a look at the simple service file, a service file then has main elements that would be in all unit files. So the description, any defaults. We can then add in the service element, as this is a service unit. Here we're running the commands losetup and part probe. So we can enable it, we can install it, or add it to a target. A target is a way of grouping services together. And we're putting this in the local fs.target. To be able to understand this, though, we're best off creating this ourselves. If we want to use a service file rather than creating it, it is provided through the course downloads or through my Git repository for this course. And yes, we're going to dive out to our command line so we can learn a little bit more about working both with disk files, but more importantly, as service units. We're going to be using fallocate to create the disk file. losetup can be used to link it back to the file. Parted can be used to create our partition table, and then we can use systemctl to run the edit to create our service unit. So come on, let's go through and take a look at this. Now here we are working on my Ubuntu One system. We've got the host name of main now, which we can see. If I use the command lsblock, obviously we are running as root, we're able to see our block devices. Ubuntu does make good use of disk files that can be used to link into our device files, loop 0, loop 1, 2, and 3 in this case, as well as having then SCSI disks A and SCSI disk B with one partition on A. Now, if we wanted to create our own disk file, we can use the command fallocate to go through and create the backend disk file. So we can specify -L to be the length, and we'll have it as 1 gig, and we'll write to disk 1 in the root user's home directory. ls-lh, remember H for human readable, and if I use escape and dot to bring up my last argument, we can then show the size of 1 gig that we've created. But this is not a device file, it is just a file in the file system. So we need to use lo setup, and we can link then /dev/loop10. I'm just really using a random number here to make sure it's completely clear of any other loop devices that we might be using. We saw that we were using 0, 1, 2, 3, and maybe even 4. So this is just clear enough to be not conflicting with anything else that's being used on our system. I'm going to link it to the root user's home directory and then the disk1 file. If I run the lo setup command now, we're going to print then our loop devices, and we can see then that we've got 0, 1, 2, and 3, and then loop 10, which is linked back to our disk1 file we've just created. Now that we've got a device file, we can work with it. And if I clear the screen, just to make the screen a little bit more readable, so Control and L, and then parted/dev/loop10. Make sure we are working with the correct loop device. And we can then go through and put muck label to create a partition table. It's called a disk label. We're setting the traditional partition table, which comes from MS-DOS, so that allows for up to 4 partitions of 2 terabytes in size. We can continue to create the partition, so muck part, and we want a primary partition starting at the beginning of the disk, so 0%, or as close to the beginning as we can, going through to the end of the disk. The partition we can use later for a file system. Now when I go through and look at my ls block, we can see that not only do I have the loop 10 device, but we've got the partition. Now this all might look good, but if we did really wanted to use this for a file system and have it mounted on system boot into a directory, we're going to find that we don't find the loop device or its partition. Let me show you. If I go through and do a reboot, so of course then that shuts my system down, and of course is going to disconnect me, so I'm back on my host system. Control and L though will clear my screen here, and we can go back up using Vagrant. It's Vagrant SSH back into my Ubuntu One system. Once the system is back up and running, I'm going to be able to connect to it. And again, if I go through using my root permissions and then ls block, when I look at my block devices, I don't have that block device anymore. Now, of course, it's not causing me any problems because I didn't try to mount a file system, but it would have caused me problems if I was trying to auto-mount a file system. If I look, though, using ls, I can see I still have my disk1 file, so that is still there. But of course, I've got to run the lo setup command to link it to the device. Linking it to the device, so it's not going to give me my partition table, I've got to use part probe to read the partition table. And that's where a service unit can be really useful. Let me quickly go through and download the repository. So if I use git and clone, we can go through to https and then github.com, and then we're going through to the Urban Penguin, and we want to pull down the LFCS repository. Now in here, if I go through and cat out from the LFCF directory. We've got then the operating course, and then we can go through and take a look in the etc subdirectory, systemd, system, so exactly where we would find it on our system, and then we've got the LO setup service. So this is the service file that we can use. Now, of course, we can type it out afresh if we want, but I'm just going to go through and grab this into my paste buffer. To create the service unit, I'm going to use Control and L to clear the screen, and then systemctl, edit, and then we'll call it LO setup, whatever you really want, as long as it doesn't clash with anything else. .service -- full, so we're creating a new and full copy. It will complain that the originating one doesn't exist, so if we're creating a brand new file, use force. Hit enter, and then of course I can go through and paste in. Under unit, we've got our description, the fact that we don't need to worry about dependencies. We want this to happen before our local file system target and after our systemd udevd, so we've detected devices. It's a one-shot service, so we only need to run the command. We don't look for it staying running, and we're running LO setup and part probe. Make sure you're referencing the correct devices and disk file. Remain after exit. No, again, it's one shot. We're not keeping it running. The install is really allowing us to enable the service, and we're saying, well, group it together with other services in the local-fs.target. I can use Control and X to save this. We can make sure that we reread all of our information, so systemctl, and then our daemon -reload. If I run ls block, obviously we don't see the block device at the moment, but we now go through and run systemctl enable, so we want it to start on system boot, -- now, we want it to be started now as well, and then our LO setup. If I go back now looking at my ls block, we can see now that I've got my loop 10 device and I've got the partition. If I reboot the system, we know that on a reboot, because the service is enabled, it is going to auto start, and then by auto starting, it is going to run those same commands. So LO setup to create the loop device, and then part probe to read the partition table. Again, clearing out of my screen, going back to SSH into it, and then clearing from here. I can run ls block as a standard user. We can see now on the reboot, look, my device file is here, and we can give everyone a great round of applause because hopefully it's looking exactly the same on yours. Now, we have talked a little bit about targets, but let's dig into them a little bit deeper. We can use systemctl and we can list our units. If we look for the type of target, rather than showing all of our unit files, we're only going to see those of type .target. Remember, our default type is .service, our service units. Targets are used to group services together. One of the things that they can be used to group services together for is to specify a run level, a target, if you like, when we boot. We can look at our current run level. Run level is really an older command and will show run level numbers rather than target names. But we'll see on our Vagrant system that we're in run level 5. Run level 5 is really representative of our graphical target. We can check this by getting our default target. So when we boot the system, what target do we want to go to? Let's say if we had a desktop system, we could boot to the graphical target and load all of the graphical programs if they were installed. Whereas if we wanted to use it as a server, we could change the default to be multi-user so we didn't load any of the graphical programs. We want to change from our graphical target to our multi-user, and don't get confused with the target name and expecting us to be loading all of the graphical programs. If they're not installed, they're not going to be loaded. But we then might prefer to drill down and change then our target to be multi-user, more representative of what we've got installed in our Vagrant system. So isolate is changing our run level. We can check that with the run level command, and we'll see now that we're in run level 3, representing multi-user. And we can set this as the default. So in future, instead of booting towards our graphical target, we'll be booting and stopping once we get to multi-user. Having set this, we can check it with our default, but the very best way to see this is to dive out through to our command lines so we can actually get the understanding by working with our targets at the command line. So here we go. Let's see if we can find our command line. Now, the first thing, if I go through and just type the command run level, even as a standard user, this is going to work for me. We say, well, it's a new boot. So we've just booted the system and we're currently in run level 5. Run level 5 is really an older representation, but it shows what we would now call our graphical target. If I use systemctl and get default, we can see that our default target, so if I don't specify a different target to boot to the kernel during the boot phase, we're going to boot up to the graphical target. Now, as I said in the slides, don't get confused with the graphical target expecting to see a graphical environment. If that graphical environment is not installed, then we won't be starting up any of those associated services. But we can see where we can get confusions coming from. So it might be better to take a look at the different types of targets that we have. So again, I'm going to up arrow key. We can change our get default to list unit and then -- type being target. If I don't include the type, we'll list all units. We can see then that we have different types of targets with different names. Some of these targets we can actually set to boot to, such as the graphical target or the multi-user target. Others are just used for grouping services together. One target can include other targets. So, for example, the graphical target will include all other targets below it. So if I set a service to start in multi-user, it is also going to be starting in the graphical target. If I want to change my run level or my target, on our system, it's not going to really make any difference, but I can use then sudo and systemctl. Let's go through, and remember I can use Control and A to move to the beginning of the line, sudo, Control and E to move to the end of the line. And we can then use isolate and then multi-user. This is really our run level 3 from the old way of viewing these targets. So we will have changed now to the multi-user target. Any services that were starting up in the graphical environment but not configured to start in multi-user would now be stopped. So if I did have a genuine desktop system and I changed from graphical to multi-user, we would be stopping all of the graphical programs. But if I now go through and use the run level command, the run level command is going to show me that I was previously in run level 5. We're now in run level 3. Run level 3 being the older representation of multi-user. We can go through and set default, so up arrow key, and then changing to set dash default, and then multi-user. Hit the big enter key. We could double check with our get default. Technically, I could run this as a standard user, but I'm not going to change the sudo. So get default. And we can see now that our default run level or target. So when we boot, we're going to be taken to our multi-user target rather than being taken to our graphical target. As I say, the effect is little, if nothing, if we don't have any of the graphical tools installed. But give you an idea of a little bit about what targets are and how we can set the correct boot target with the set default, how we can change targets using isolate. Within a traditional Linux system, our log files have been located below the directory /var for variable data and /log. This is still the case in most Linux distributions today. However, we are moving towards a newer journal CTL, so a journal log that's part of our ecosystem with systemd. We can go through and take a look inside of our log directory. The log files and which log file is written to is going to be controlled by the rsyslog.conf or its subdirectory rsyslog.conf.d. Working though with our journal log on many of our newer systemd systems, we don't need to worry about the individual files. We can just run the journal CTL command. We can drill down and filter to see the information that we need, such as by looking at service unit. So here we're looking at those messages being reported by the SSH service. We can also bring in a time element. So if we put in -- since today, we're only going to be seeing messages produced today. By default, the journal log, though, does not persist. If we want to persist it, we can go through and check for the entry storage within our journald.conf. We can always check inside of our man page, so looking at man5 journald.conf, to see what settings are available. To make the setting persistent, we can just edit our journald.conf, but another way of editing is using the sed command. Here we're looking for the string storage equals auto that is commented out and changing it to storage equals persistent, so the whole line is replaced, so it's no longer commented out and it has the value of persistent. Once we've done that, we can go through and check the change has been made, and then we can go through and restart our journald service. Now, as always, the best way to see this is directly from the command line. We're going to be able to see that working with logs, we're going to be looking at our logs and using the tail command. We'll be viewing our journal log and persisting our journal log. Look, the serenity of our command line. But our command line we're about to shake up by looking at our logging systems. So var log. This is where our traditional log systems will be rewriting to. We have individual log files or directories where we can organize our logs. But we have to know which log file to go to. But not just that. We've got to work out how to filter information. If I show you how we might read a log file, we can go through and open it with sudo, and we can use the page ls. And our main log file inside of Ubuntu is var log and syslog. Now, this is a very long file. We can page through it, but we can see we've got to search for the information that we want. Now, one very simple way is to use the tail command, so we can see some practical usage of the way in which we've looked at reading files before. So sudo tail, and then /var log syslog, or use escape and dot to recall the last argument. If we want to follow the end of a log file, rather than just reading the last 10 lines, we can follow our log file. So we can see in this situation, it's being written to by the multipath daemon, multipath D, all of the time. Now, it's just a misconfiguration where we've included the SDA and SDB disk to be as part of multipath. They don't need to be, and it produces errors. Now, this is not us, it's just Vagrant, or the people that built the Vagrant virtual machine. But it gives us an idea. By reading our log files, we can see possible misconfigurations that we could tidy up. To stop following the file, we can use Control and C, and that just gets out of following. But we can see how useful tail -F can be. The configuration of our traditional logging comes from the file etc rsyslog.conf. Generally, though, here there's not a lot of configuration, as we're pointing to the extension directory rsyslog.d and any file in there *.conf. So as we go through and take a look in /etc rsyslog.d, we can see that we've got 3 configuration files, most of which, though, most settings are going to be found within r50-default.conf. We're not going to spend a lot of time looking at the more traditional log system. We're going to take a look at the modern journal.ctl, part of our ecosystem sitting around systemd. If I just run sudo and journal.ctl, we look at the complete journal log. Rather than having separate files, it's just one reference point that we can go to with journal.ctl. But we've got our own filtering tools. So I can use --unit SSH to only look at reports, messages coming from the SSH service. But I can up arrow key and drill down even further, and I can use options such as --since and --until. So if I put --since today, we're only looking at events that occurred today. It's August the 24th today. So these become really great ways that I can go through and query my logs without having to know too much about it, as well as having the filtering tools to allow me to read the information that's important to me. If we want, though, the journal log to persist, we can check the journald.conf. If I go through and use grep-i for case insensitive, and then if we go through and take a look at storage, inside of the configuration file, which is going to be etc systemd and journald.conf. Now we can see it's commented. This then shows me a default setting, and it's set to auto. Auto, we will persist if the journal D directory or the journal subdirectory exists underneath /var/log. In our case, it actually does, but we might want to force it to persist. We can check the settings that we can have underneath storage by reading man5 and journald.conf, so the man page for the configuration file. We don't need to go far down. And when I look at my options, we can see storage equals, and we can see it can be set to volatile, persistent, auto, or none. We want it set to persistent, so we're forcing the journal log to be stored. With that then research, we're able to edit the file. Now, we could just use Nano to edit it, or Vim, but we can also use our stream editor. sed-i is doing an in-place edit. Open up our single quotes for our sed command, and we're going to use the substitute command. We're going to look for the string To get this accurate, we've still got the grep command showing. I'm going to take the results of searching for storage and paste that in, which is my commented line. So we're searching for that commented line. I'm going to paste it in again, but I'm going to change it to be uncommented. So we're going to replace the complete line to be uncommented. And instead of storage equals auto, we're going to carefully type persistent. We've double checked on the spelling of that now, so we shouldn't make a spelling mistake. So we should be good to go with this. And I can use escape and dot a couple of times to get back to etc systemd and journald.conf, the file that we want to be able to edit. But here we can then edit our file non-interactively and directly from the command line. If I go back now and take a look, we can see that we have in fact made the edit. That's really good. Now that we know we've got the correct settings, we can go through and restart our service. So systemctl restart and then systemd-journald. So we know we are making use of these persistent settings rather than the auto setting that was before. But come on, let's return to the slides so we might summarize just a little of what we've enjoyed in this module. And yes, look at you. You've got to the end of another module and a big hearty well done. We've been taking a look mainly at managing services. Now this started by taking a look at process ID 1 on our modern Linux systems such as Ubuntu 20.04 and seeing how we've got systemd as process ID 1 and how that offers a certain amount of uniformity across our Linux distributions. We can see that through the use of the hostname CTL command, the locale CTL command, and the time-date CTL command. Irrelevant of the distribution, so long as it's a recent Linux distribution, we're going to have these commands available to us, and they're going to work in exactly the same way, irrelevant whether it's an Ubuntu or a CentOS system that we are looking at. We've seen, though, we can extend these control features into managing our services, and that's what systemctl is all about. With this, we can start, stop, enable, and disable our services, all with the one command, as well as being able to do things such as cat and edit our services and mask services to prevent startup. Behind our services, we have service units. These are just text files. We can cat out the contents so we can view the contents of these files, but we can also use systemctl and edit a unit file. We saw that we could create our own unit file to help us automate a process of linking a back-end disk file to a loop device. We looked at how we can manage targets. Targets are a way of grouping our services together. And we finished up by taking a look at our traditional logging system, but spending a little bit more time looking at our journal logs. Our journal logs, then we can see what's happening on our system and what services are reporting very easily without the need of going to individual files. All of our filtering is managed from the journalctl command itself. Now, as I say, at this point, you really do need to give yourself a really good slap on the back. You've done an amazing job. But don't forget, this is just part of a journey that's going to continue in our next module, where we're going to be taking a look at scripting automation in Linux. Yes, you're going to learn to write your own shell scripts. Hello, and a big warm welcome to you to this Pluralsight presentation. A presentation where we're going to take a look at the module Scripting Automation in Linux. My name is Andrew Mallett, and I'm going to be your instructor for the duration of this module, a module where we're going to be understanding a little bit more about shell scripting within our bash shell. As we work our way through, we're going to be taking a look at loops, conditional statements, using variables, using commands and built-in commands, using redirection, and other common utilities that we might include either at the shell or within our scripts. Now, a shell script is simply commands that are grouped together inside of a text file. They can be executed by bash itself, or we can configure the executable to use from within inside of the script, the shebang line that we'll look at later. Not just commands, we can also add to these commands operators. Operators can be used within our scripts, but also we'll see we can use these operators in the shell itself. Now, some of the operators that we use might vary from shell to shell, but we are concentrating on bash. Now, when we're writing a shell script, we might tidy them up into a directory. So we can begin by creating ourselves a project directory, if you like, for shell scripting. We can use any editor that we like. So we can use Vim or we can use Nano. We call the script itself info.sh. Now, we don't have to have an extension, and theoretically, these aren't actually extensions inside of Linux. We have a file name. We don't carry the concept of names and extensions. So we could call it info, we could call it info.sh, but this is just the name of the script. If we've called it info.sh to execute it, we must type info.sh, not just info. We've got the echo command. The echo command is just printing out, in this case, some header information. Host name, we probably can guess, is going to return the host name. But we can also return the IP address. So using the uppercase I, we can list IP addresses associated with this host name. uname -r is just the command to show the kernel release. And then we can finish it off with our footer information, having the equal signs being printed out again. So this is really what we mean by a collection of commands. The echo, hostname, uname, and echo commands join together so they execute in a repeatable manner. Once we've created the script, we can then go through and execute it. The simplest way is just to go bash and info.sh. But of course, we might want to make this stand alone so we can run it as its own little program. What we must do is interrogate the file. It will just show at the moment as just an ASCII text file. If we go through and add in the shebang, which is just the first line of the file, we'll see what we're doing with the sed command, but we're inserting on line 1, the first line of the file, then hash exclamation mark /bin/bash. So we're adding in that as our first line. We now go through and use the file command again. It will interrogate the file and will now show that it's an ASCII executable that's been formatted in the born again shell script format. We can make it executable. A+X is adding the execute permission to all blocks. And then we can execute it. We can execute it from the current directory, so ./info.sh. Including it within a directory that's part of our path statement, we would be able to just run it as info.sh, whereas if it's not in our path variable, we run it as .info.sh. Now, we start getting into explanations like that in a slide. They don't make a lot of sense, do they? The best thing is to actually go through and see some of this magic happening and get the idea of why we might use sed rather than editing the file directly. We could, of course, but this just becomes a quick way to make an edit, and we could make the same edit across multiple files by using something like an asterisk if we wanted to add the shebang to each one of our lines. So come on, I'm going to challenge you to join me at the command line, and we're going to get stuck into our first script. And yes, our first demonstration where we're going to be working on our Ubuntu One system. We can go and create directories for our scripts, adding a new script, using sed to insert that shebang line, and then adding the correct permissions so that we're able to execute it independently of bash itself. So come on, let's find that command line. And here we are at the glorious command line. And I think you would agree, wouldn't you? This is an absolutely glorious command line. So I've fired up my Ubuntu One system. We're back at the Ubuntu One name. I've gone through and just cloned a new image to be working with. So we're clean and fresh for this module. We can go through and create ourselves a little directory. This is just to organize. So if I go through and create then a shell scripting directory, I'm running this from my home directory, so it's going to create it in my home directory. And let's just see if we can spell it vaguely correctly. We can move into that directory if we want. So cd, escape, and dot. Remember, escape and dot can recall the previous argument. And we can see now when we look at pwd that we're in home, vagrant, and shell scripting. Now we're ready to edit our scripts. We can use Vim or we can use Nano. It's really our choice. We just need a text editor. So we'll stick with Nano as there's nothing too much we need to be able to do with this. And then we can create a script that we're going to call, let's say, info.sh. Now to begin with, we can then go through and just echo out some information. So echo will just print to the screen. If we then go through and just put in a whole load of equal signs, then we can have kind of a header feel going on. Once we've got that, we can then go use the hostname command. The hostname command, well, is going to print out the host name. We could probably have guessed that. But hostname minus uppercase I might be more difficult to guess. Remember, we can always look at our help, so hostname minus help, or man hostname, but this is going to print out our IP address. We can use uname minus R, that's going to print our kernel release. And then we can get back to our echo statement, and then we can echo out a whole load of equals signs again. And with this, we've got to kind of just guess that we're putting in the right amount. If that looks roughly okay, it probably is. Maybe we should have one extra one. We'll see ways that we can generate this, though, to get a more accurate representation of our header and footer. Now, this is really a very simple script, but to show you really all that a script is a collection of commands and operators. We can use Control and X, yes to save, so just Y, enter on the file name. And remember, we can always go cat and escape and dot, so we can then see what we've created. If we look at the permissions, ls minus L, so let's get a long listing of the file. We can see that it's read-writable, and readable. We don't have any execute permission in. But that doesn't mean it can't be executed, but we can open it up with bash itself. So we can run bash. So it's bash that is executing, and we're getting bash to open up the info.sh file. It then goes through and prints, and we can see then that we get our header and footer, the hostname Ubuntu One, and then we are able to see our IP addresses, and we can see then the uname, our version of our kernel coming out. Remember, we can always go through and take a look at these commands. So if I use hostname minus help, we're able to see what switches we can use with this. If I clear out my screen, when we look at the command uname and minus help, we can see then all of the options that we can use with this, and we can see that -R is the kernel release. So again, do take the time to look at the help as well. Whenever you run a command, if you've got a little bit of time associated with it, why don't you go through and read the associated help? You never know what you're going to find out. If we want to, though, execute this ourselves, independently of bash, we need to specify the script or the interpreter that is going to interpret the script. And we can do that through the first line of the script. It is called a shebang. Now, if we just wanted to edit one file, then we could just open it up in Nano. But what if we had two files? Let's just go through and then copy our info script through to info2.sh. So now, of course, when I list in here, I've got those two scripts. Neither have a shebang, so I'd have to edit it twice. This is where our stream editor or sed can come in. If I use sed -i to do an in-place edit, open up our single quotes, and then we can go and run our command, which is 1i. On line 1, we want to insert a new line, so a new first line, and then the contents of that line. That's going to read then as the shebang. It's a commented line, so it's not read by the script, but read by the system. And then we go through and put !bin/bash. So we're setting bash to be our interpreter. As we then go through and run it, we can run it on the info file, but we could also then go through and do info*. So we're going to edit all files starting with info. If I now go through and cat out the info file, we can see then that we've got the new line, as well, of course, being in the info2 file, we've got the new line. So, of course, I do understand that it is easier if we're working just with a single file, such as we are in reality, to just use the editor. But if we can become more familiar with some of our automation tools, such as sed, we can make life a lot easier for us when we need to work on bulk. If I go through now and take a look at our file, if I go through and look at file and info.sh, by adding in this information, the system now knows this is a born-again shell script that's an ASCII text executable. Now, it says that it's executable, but the execute permission is still not set. So I'm going to use chmod to change the mode or permissions of the file. Using -v, we actually get to see the permissions changing. And I'm going to go and put all plus x. So I'm adding execute to all blocks. For then, again, I can use info and asterisk. So any file starting with info. We can see then that we've affected two files, info and info2, and we can see the new permissions include the execute permission. With that set, we're able then to run through our info.sh. We're running it with our path because it's not included in our path variable. The shell scripting directory is not part of our search path. So we have to specify the path through to the variable. So we have to specify the path through to the program. But we can see now it's executing perfectly okay. If we take a look at our path variable, so $path, we can see that if we added the script to any of these directories, then these directories would automatically be read. If I wanted to include the shell scripting directory, I could then go through and have path equals, and let's say read in the $path, but add to it my home, Vagrant, and shell scripting directory. So Vagrant being my user account. If I go back now and echo out my path statement, we can see now it does include the current directory, but I can move away from that. But because shell scripting is included in my path statement, I can then go through and run info.sh, We can search through the path variable, and that's going to work for me. It's going to work for this shell, but not for other shells because I haven't added the path statement to my login script. But there you go, a little bit of a simple script and how scripting works inside of your bash shell. Now, we don't want just a script. We want a rockstar script. And we're going to be able to add variables that makes the script just a little bit more readable and useful. Also, the header and footer, we could see that it was quite difficult to count the exact number of our equal signs. So we can actually produce a line automatically using a looping structure. So if we take a quick look at what we're going to create, is we're going to add in some variables. So info hostname equals the output of hostname, etc. When we're looking at our IP address, we can pull out just the second IP address using the cut command. For our looping structure, we can go through and use a for loop, and we can say for our number I being in 1 through to 25, we can then go through and echo them out. Echo minus n is making sure that we don't print a new line. Otherwise, each equal would be on a new line. We want a line of equals, so we suppress the new line. We can then go through and start printing out our variables, but include some information like host and then info hostname, IP, and then info underscore IP, and so forth. And then we can repeat that same information with our looping structure to print out that line. So we're going to move straight through to our command line and take a look at improving our script just a little bit, adding in loops to generate the headers and footers, and using variables to collect data. And rockstar script, here we come. Let's move back into our shell scripting subdirectory, and then we can go through and nano our info.sh. Now this works, and we know that it works, but let's go through and try and start improving it just a little bit. As we go through, we can go through and start setting up some variables. Variables don't have to be in uppercase, but very often by convention they are. Info underscore host name. We know now what's going to be contained in our variable by the name of the variable. So it's adding documentation equals and then $. We're looking at the output of the host name command. So that's simple enough, and we can continue as we do this with info underscore IP. Now we saw before that it was producing two IP addresses. We have two interfaces, so the uppercase I is printing both. But we can go through and again look at the output of the command. We were looking at host name minus uppercase I. So that produces our list. But we can then pipe the output just as we would on the command line through to cut. We can look for field 2. We want the second IP address. That's going to be our 192.168 address range, where the field delimiter is a space. And then finally, it's a more simple one. We're back to a simple command with our info underscore kernel. And that's going to equal, we know the deal now, the output of our uname minus R. So that's collected our information, stored it in variables. The variables being very readable, we're able to see what we're printing later on. We can go through then and start printing out our headers and footers. So we can then say for I, this is just a temporary variable, I really just for integer in, and then we can specify a range. We can do that with our brace brackets in 1 through to 25. So 25 equal signs should be more than enough. We can always adjust it if it's too many or too short. We can go into our looping structure. We don't need to space in, but it's going to make it more readable if we do. So inside of the code block, we're going to then echo out, suppressing the new line, and equals. So we can get 25 equal signs, and that's it, we're done. We don't need then the manual representation of that anymore. And then we can go through and clear out these and start printing other information. So let's clear all of this out at the moment. We can echo just an empty line, and then we can go through and start printing the information that we need. So we can now start including a little bit of extra information. We can have our host colon and then our variable. With this, we have to use double quotes to make sure that we do expand the variable, so we read the content of the variable rather than just printing literally the dollar symbol. But then info underscore host name, we can echo out our IP and then dollar info underscore IP, and then echo our kernel, and then we can go through and use the variable dollar info underscore kernel. We can have again a clear and empty line after that, so just the echo command with nothing in it. And I'm just going to go through and paste in the footer. Again, if we want, we can have a clean and empty line just after that. But there's our script. So a little bit longer now, but hopefully it becomes a little bit more readable. And of course, we're only printing the single IP address. So if we use Control and X, Y to save, enter on our file name, and then go through and execute our .info.sh. We can see now that we're getting our information. We've got just the single IP address, but we've got the extra information like our host and our IP included. So we're getting a little bit better, and obviously we can adjust so it works well for us. But it seems that 25 was about the right number of elements to have in our header and footer. Now, especially if we've got a script like we've created, the info script, there's lots of info we can get from our operating system. If we take a look at the file etc/os-release, we'll see that is just populating variables. If we want to make use of that within a script, we can use the command source to read in another shell script. With that done, we can then go through and echo out any of the elements that we've imported, the variable names, such as the pretty name. Now, we're doing this from the command line, but there's nothing stopping us doing this from a script. And that's what we're going to be taking a look at. We're going to be using the built-in command source to add imported variables and the functionality through to our script. So come on, let's go through and import some variables. So let's begin our command line by going through and cutting out the /etc/os-release file. Now, when we take a look at this, we look carefully, we can see it's exactly like configuring variables because all of these are configured variables. So we've got things like the name, the version, the ID, the pretty name. If we want to use these variables, we can use the built-in command source. Again, if I use the escape and dot, we read in our last variable, and that's now set those variables in my current shell. So I can then go through and echo out, let's say, $name. When we take a look at that, we've got Ubuntu. If we go through and take a look at, let's say, pretty underscore name, then we've got our Ubuntu 2004.4 LTS, and so forth with any of the others that we might want to be able to use. So let's clear our screen, so Control and L. Let's go into our Nano text editor and open up then our info.sh. We can go through and add in a new line. So after our shebang, remember the shebang has to be the first line. We can then go through and source, so read in from our etc and os-release files. That has our variables set. Obviously, we need it spelled correctly, otherwise it's not going to work. So that gives us some variables that we can use. So if I wanted to add in extra operating system information, I could then go through and use the echo command, and we can go through and print out the, we'll just call it, let's say, operating system. And we can go through then and put our $pretty underscore name. Close off our quotes. I think we probably had one too many echoes here, so let's take that echo out. That was adding in an extra line that we didn't really need, so we can tidy that up now. So the source command is reading in our variables from another file, and then we're using that variable, the $pretty underscore name, within our printout. So we can use Control and X to jump out, Y to save, and enter on our file name, and we know now we can go through and execute it with our info.sh or .sh, just missed out on that, and we can see now that we've got that extra line, our OS being Ubuntu 2004.4. So again, don't worry about using system variables if they're available to us, and take a look at anything that you might be able to use in the etc and os-release file. Now we've seen the loop that we've created so far using the for keyword. We can also use while loops. Now this might look a little bit too much to have on one slide, and I do accept that these are not necessarily great ways of displaying information. So we're going to be stepping through this in our script later from the command line. But it gives you in the slides at least a hard copy that you can look at. But don't forget, supplied with the course, we also can download demonstration files along with the Git repository that we took a look at previously. Again, we'll revisit that towards the end of this module. So we're going to move out to our command line now to investigate this password generation script. We're going to be taking a look at using variables, while or until, reading user input, testing the length of entered data. So if we want to make sure that we've got a certain amount of characters within our password, we can do so. And we can use if statements to control when the looping structure is ended. So come on, let's dive out to our command line so we can see how this is going to be done. And look at this, a glorious command line. What we're going to learn a heap about scripting. So you can see I'm in my shell scripting directory, a good directory to organize all of my scripts. And we're going to go through using whichever text editor we want. I'm using Nano here. And we're creating a new script, pwgen.sh, a password generation script. We're going to go into this and prompt for user input and see a whole load of features that we can use. But to begin the script, we know what we're going to put in, don't we? Yes, we do. It's going to be our shebang. So the commented line that has the exclamation mark /bin/bash. So that tells us which script interpreter to use. And we're going to begin by configuring a variable. We're just going to call it pwd_OK. and we're going to set it to a value of false to begin with. It doesn't really matter what we set it to, but we're going to be checking for a certain value, and we're going to loop round whilst that value is not met. Now, we're setting this variable to be false. Once our password is okay, we can set it to true. And this is going to control the execution of our while loop. Within our while loop, we can put a test condition. The test condition is defined within our square brackets. So open up your square brackets, and then we can go through and specify that we want to test our variable. So $pwd_OK. Generally a good idea to put our variables in double quotes, so it protects any special characters that might be inside of our variable. And we're going to say whilst it's not equal to, so exclamation mark equals not equal to true. Now we've already seen then that we've set this to false, so we know we're going to go into our looping structure. So in our looping structure, we can set our password. We're going to open up our do loop. So we end our while line with a semicolon, put a new line that contains the word do, and that opens up the code that's going to be contained within our while loop. The first command we're going to put in is to prompt for user input. And we do that using the read built-in command to bash. -s suppresses any echoing of information. We're going to be prompting for a password, so we suppress that. The -p is for the prompt, and we're setting our prompt to be a user guide. So enter a new password. And generally, I'm going to want a colon after that and a space, and then close my quotes. We want a space so it separates the prompt from any of our user input. It just makes it more usable. Now, if we don't specify the variable name, read is going to store that in a variable called reply. We can put a clear and empty line after that, just using the echo command, just to make sure that we are starting a new line. And we can go through then and set our variable of pwd_length. We might want to make sure that we put in a certain amount of characters so we can echo out, suppressing the new line because we don't want to count the new line that echo normally has, and the $reply variable. Remember what I just said about the read command? The read command, if we don't specify a variable name, will populate a variable called reply. So we didn't specify the variable name, so our password is going to be stored in reply. Word count -m counts the number of characters. So that's why we were suppressing the new line. We didn't want to count that. And we can store then the length of the reply variable in our pwd_length. We're going to use that because we want to check that we've got at least 6 characters later on. Moving forward with our script, then we can actually set our encrypted password. So password equals, and again we're looking at the output of commands. So much of our bash scripts will be this, using variables, and those variables are going to be populated by the outputs of a command. We want our password to be encrypted so it can be used by our user_add command. So we're using OpenSSL and the passwd, that's passwd, not password, module. -6 specifies the algorithm to use, and this is the highest algorithm we currently have, SHA-512. And we're using then our input of being then $reply, the password in clear text that we've just entered. So the password variable is going to contain an encrypted version of our password. But remember, we need to check that we have the right number of characters. So we can go back and actually use an if statement now And the if statement can go through and test the condition of our pwd_length. This was from our original $reply, our clear text password. Within our if condition, again, we're using those same square brackets for the test that we used within our while loop. We're looking then for our pwd_length. And this time we want to see -GT, so greater than 6. So we only carry out what's inside of our code block if our password is greater than the 6 characters. Our code block is defined by the then keyword. Again, we don't need to indent, but indentation is going to make our code blocks easier to read. And we can go through then and specify our pwd_OK. So this is controlling the main while loop. We can set this to be true. We don't need to loop anymore if we've got the correct password length. And we can echo out the encrypted password hash. With that done, we can make sure that our password is just inside of quotes. And with that done, we can end our if statement. Our test condition is done now. So fi, the reverse of if. And don't forget, we still got our do block open. Our do block is ended with the word done. And that's it. That's our script, line by line, character by character. Once we're ready with it, we can do a quick once over, but if it's looking okay, we can use Control and X in Nano to be able to save. And then Y and enter. Now, of course, we've got to set up our permissions. We've got our shebang, but we can then go through and use chmod for change mode, all plus execute. Now we can execute it ./pwgen.sh. The read command prompts for our password, so we enter it. We can see then I must have entered more than 6 characters because I'm getting my password coming back, the encrypted version. But if I run it again and put, let's say, a 4-character password, I'm stuck in the loop until I do then choose to put in a 6-character password. Once again, I've got that 6-character password. We're all okay and up and running. Another really useful feature of our script are passing script arguments. If we take a look at how we can improve our script, we can use $hash to count the number of arguments that have been supplied. We have $1, which would be our first argument, $2, which would be our second argument. $hash is the number of arguments. $0 would be the name of the script. So we're going to dive out to our command line now, looking at how we can improve our script. We can make sure that the script actually exits if our password is too short, and we can only prompt for our password if we haven't supplied it as an argument to the script. So here we are back to edit our file. So I'm going to open it up in Nano. I'm going to start adding some great functionality. So of course the script's been left exactly the way that it was before. Computers are good like that. We leave it in one condition and we come back and find it in the same condition. But we want to add a little bit of functionality. At the moment, we have to go through and enter a password, whereas we could enter a password from the command line as a script argument, in which case we don't want to prompt. So we can test our script argument. So we can use our if statement. Now we've seen that we can use our test condition with single square brackets, but we can also use it with double square brackets. It adds a little bit of functionality and can ease some of our testing. I don't need to quote my variables for a start. And I can then go through and look for $hash being the number of command line arguments not being equal to 1. We can close off the double square brackets. And don't forget then, a semicolon is going to end our if statement. And we can then start our code block with then. So if we haven't provided the argument, we have to prompt for our information. So that's our original read and echo. But we can extend our if statement with an elif or an else. We've just got the one other condition to test for, so we can use else. So if we do have exactly one argument, then we're going to match our else statement. And for this, then, we're going to set our reply variable, because, of course, the reply variable is not going to be set in this instance by the read command. So we can set reply to be equal to $1, $1 being our first argument. $2, of course, would be the second argument. Don't forget $0 would be our script name. We can end our if statement with the fee command. And we're going to make one more change here. Rather than being stuck into a situation where we're looping around if we provide a short password, we can go into the if statement and run an else. So if we don't have the correct number of characters, we can specify that our password is too short. So we're looking for greater than 6. Obviously, if we're not greater than 6, our password is too short. So we can provide a little bit of feedback to the users, which is always good. But rather than keep looping around, we can exit. And normally we exit with a code of 0, which is a success. Anything other than 0 is a failure. So we can go through and exit 1. And we can then determine what happened with our program by querying the exit status. So exit 1, we're saying perhaps is a password too short. We can go through and save our changes, and with those changes made now, we can go ahead and execute. We don't need to set our permissions. Our permissions will still have execute. Now, running a short password, we can see then that we get our password too short and we leave straight away. We can check the exit status by reading the special variable $? And look, it's got that exit code of 1. If we clear the screen and run our script again, but this time type a longer password, we can see then that it's all working fine. If we check the exit status, exit 0 is success. The command didn't come across any errors. But again, if we go back up and try now entering a password, we'll put in then the required number of characters. We're not going to be prompted now for our password because we've provided that as our argument $1. But of course, the same password check, the length check is going to be there. So if we put in, let's say, just 4 characters pass, our password is too short. And again, we're going to be hitting that same error code where we have an exit code of $1. So we're able to implement a little bit more checks into our script and then decide whether it should be used interactively or directly from the command line. Now we're going to go through and look at creating users. We're going to be working at the CLI rather than the script, but we want to be able to show you that we can still use loops from our command line. We're going to loop round creating our users from a list that we supply, but generating passwords from the script that we created. So here we are then back on our command line, and we're going to take a look at using loops at the command line and creating users. We're not going to spend a lot of detail looking at our user creation. We'll see that later. But we're going to begin our for loop. So for user, a temporary variable, in, then the list that we supply. So we've got users Joe, Jill, and Sam. That's the end of our list and the end of our line. So we put our semicolon and run a new line do. We can hit enter to end our line here, and it takes me to the continuation prompt. Now we need to elevate our privileges to create a user, but users are created, would you believe, with a user add command. As I say, we won't spend a lot of time looking at that at the moment, but we're going to be creating the user home directory, so -m. We're specifying the default shell for our new users to be /bin/bash. And -p allows us to go through and specify the encrypted password. We can't provide a clear text password. It has to be an encrypted password. Thankfully, we've got a perfect script to be able to do that. We can go through then and look at the output of our pwgen.sh, and making sure that we don't need to prompt for the password. We can provide the password as an argument to our script. We then need to specify the user account that we are creating, and that's where our temporary variable comes into play. In our looping structure, we said for user, so we're populating a variable called user, or $user as we're going to make reference to it, for each iteration of our script. And that's all that we need to do. It's going to create the 3 accounts with the password set to password123 ? But the encrypted version. We need to end our for loop with the done keyword. And as soon as I hit the enter key, it's all executed. And as simple as that. Now we can check that work has actually taken place by revisiting our tail command. So tail -n3, show me the last 3 lines from our user account database, which is /etc/passwd. So we can see the 3 user accounts that we have created. So this all looks very good, but we're unable to see from this file the actual passwords. So we can elevate our privileges, again using tail -n3, but this time the actual encrypted passwords themselves are stored in the etc shadow file, which is only accessible by root. So we can go through and take a look at the passwords that we've set. And again, we see for Joe, Jill, and Sam. But even though their clear text passwords are exactly the same, the encrypted password is going to be different for each of our users. So this is a very important security factor. So we're not storing exactly the same password. So anybody who gets access to this file can't see users who have got the same password. When I go through then and use su-joe, we can test that he's working by putting in the clear text password the way a user would normally authenticate. And there we go. We've got access to the Joe account using the password 123 and ? I can exit back to return to my Vagrant account, but we've seen then how we can make use of our pwgen.sh from a command line loop, creating 3 users, ensuring they've got 3 different encrypted passwords, but using the same default clear text password. Now we're going to return to our slides now, and I encourage you to do this. So we're going to summarize just a little of what we've seen within this module. Now, both through the course download, but also through my Git repository, you're able to access the sample scripts that we've used. I think it's always a good idea if you can try and create the scripts yourself, but at least you're going to get a hard copy, a file copy of the scripts that we've created. So you can go through and use the git clone command, pointing through to https and github.com, the Urban Penguin, and the repo is lfcs. This will then download into the directory that you've run the git command from and create the subdirectory lfcs. Looking in the lfcs subdirectory, you should be able to use the operating subdirectory representing this course that we're looking at, and from there you should be able to then see the shell scripting directory. So make good use of the resources that are available to you, but don't just copy and paste. But we've been taking a look during this module at shell scripting using bash. We've seen the file command to interrogate our scripts and seeing the difference when we add in the shebang. We can use echo. We also saw that we could suppress the new line with echo -n. With the read command, we're populating the reply variable by default. We can silence the input with -s so we don't see what we type on the screen, great for passwords. And don't forget -p is for our prompt, the message we want to display to our users. We've seen creation of our for loops. We can also use then our for loop for using brace expansion, when we can then set our range. So we started off by taking a look at those equal symbols for I in 1 through to 25. So we could print out very easily 25 equals signs for our headers and footers. We've looked at how we can use our command expansion. So uname -r being used to populate a variable. And we've seen the source command where we could read in the os-release file, which have a whole load of variables that are configured. We've also seen that we can use while, but we could use until as well. They're really the same structure, but just looking at the reversed test conditions. And we've seen then that each command is going to produce an exit code. We can read that exit code with $? They're just some of the special variables that we've looked at, but we've looked at other special variables such as our argument count, such as $ and hash. But that's it. Hopefully you're going to practice with your shell scripting and find it really useful in your Linux command, let alone being able to do it for the exam. But next up, we're going to be taking a look at how we can schedule tasks in Linux. So looking at things like the @daemon, the cron daemon, as well as systemd scheduled tasks. Hello and a big warm welcome to this Pluralsight presentation. My name is Andrew Mallett and I'm here as your instructor to help guide you through the module Scheduling Tasks in Linux. Now, as we work our way through this module, we're going to be understanding just a little bit more about task scheduling in Ubuntu 20.04. We're going to be taking a look at systemd timer units, cron, and @. Now, traditionally, when we've been talking about scheduling tasks, we will have talked about the cron daemon. The cron daemon has been traditional in Linux, where we can then go through and schedule regular tasks to run. But we also have the @daemon, and more recently, part of our ecosystem with systemd, we've got timer units. When we look at each one of these, the cron daemon, as I say, has been the traditional and stalwart of our task scheduling. It's great for scheduling jobs at regular intervals. Now, that might be running something like a backup that we want to happen maybe once a day, or maybe something where maybe every 6 hours or so we want to update our apt database. If we need something to happen less regularly, we can use the @daemon. This might be really good when we need to migrate data at a public holiday. So we might start on our Friday evening, giving us plenty of time to migrate the terabytes of data that we might need to from one storage system to another storage system. But of course, we don't need this done on a regular basis. But the new kid on the block is the timer units, part of systemd. And the great thing about this is we don't need additional services. We don't need the cron daemon running. We don't need the @daemon running. We just need systemd running, which will be running in any case. So we don't need that additional service. Now, because this is the new kid on the block, we're going to start by taking a look at our systemd timer units. One of the first things that we might remind ourselves of is, of course, documentation. The documentation is going to be really important to you, both in the real-life environment as well as the exam. So if we need a quick reference as to how to create a timer unit, why don't run the command man5 systemd.timer. Once we know what to write, we can create ourselves a service unit. Now, the service unit is going to be really simple. Look at this, just 4 lines if you don't include the blank line. We've got our description and then our exec start, and we can see that we're doing a backup of the etc directory and backing up to the root user's home directory. But notice the important thing here is that we don't put the install section, so we can't enable this service unit for auto start, because we don't enable the service unit, we enable the timer unit. It's a timer unit that is going to make reference through to our service unit. And when we look at the details of this, under the timer section, we're going to then run 5 minutes after boot time, then every 24 hours, and we're going to execute the backup.service, the service unit we just saw. We have got the install section here, so we can enable this timer unit. So we enable this timer unit, and then it's going to run 5 minutes after boot, and then once every 24 hours. We've already seen systemd analyze, but there's more we can do with systemd analyze. We saw before we could use it to see how quickly our system booted. But if we use it with a verify subcommand, we can go through and take a look at the correctness and how well we've written our backup.service unit, our backup.timer unit, so we can check for errors. We can enable our backup timer. Now, of course, then we're saying it's going to run 5 minutes after boot, so why don't we go ahead and reboot our system? Once it has rebooted and we've logged back in, we're able then to go through and list our timer units. We should see that the backup timer should have less than 5 minutes to run before it's going to execute. Now, it's all well and good seeing the theory of how this works, but I'm going to encourage you to join me at the command line now as we go through and create our timer unit and our service unit. And welcome to our first demonstration, a demonstration where we're going to be working on our Ubuntu One system, and it's the only system we need running for this lab. We're going to be investigating our systemd timer units, and we're going to be creating a new service unit that we will trigger with the timer. So come on, let's find that command line. And here we are then, back on our command line, and we can start beginning to learn all about our systemd timers. There are many ways we can learn about timers, but perhaps the first way is to go through and look at the timers that we have on active on our current system. We're able to list those timers and get a lot of really cool reported information about when they last executed and when they're next due to execute. So systemctl and list-timers. And we can see then that we've got how long they have left until they next run, when they last executed, how long has passed, the unit file itself, and which service unit they are going to activate. So we get some really cool information. This reporting information is very useful to us, but we can also use these existing timers to be able to get an idea on how we can build our own unit files. So if I quit out of this, and we can clear our screen, so Control and L, and change our systemctl to the cat subcommand, and take a look at one of those timer units. We'll take a look at log rotate.timer. Don't forget we've got to put our unit type in when we're dealing with non-service units. .service is the default type. We need to then add in our timer unit. Straight away we can detect then our timer section, and we've got on calendar equals daily. So we're going to be running, well, you've guessed it, once a day. But the problem is we had too many events that were running daily. Chances are they could all run at the same time. So to cater for that, we have another setting that adds a little bit of randomization. our accuracy sec equals 12 hours. So we're saying we want to run daily, but we're saying, well, so long as we're accurate within a 12-hour period, and then our accuracy is going to be added in anywhere between 0 and then 12 hours. So if we have many services that are starting up daily, then the idea is they're not all going to run at the same time. We're not specifying the name of the unit file to execute, and it will default to a service unit called logrotate.service if we don't put it in. We can go back then and take a look at the documentation, so man5 and systemd.timer. So if there are any settings that we weren't really certain of, we can go through and research those. So if I search /ACCUR for our accuracy, we can see then that it's shown within our on calendar, but we also have a specific area that explains the accuracy sec equals. So never forget this. And don't forget to jump out of a man page, we can use Q. Now I know we are looking at timer units, but probably the first thing we're going to do is use systemctl edit to create a service unit. It's our timer unit that will trigger our service unit. So I'm going to use systemctl edit and backup.service. We can do a -- full and then -- force because the file won't exist at the moment. Now it's going to complain because I haven't used sudo, but this becomes a valuable lesson where we can remind ourselves about sudo and bang bang running exactly the same command and arguments. So these are always great points to remind ourselves as we go through of what we've previously learned within the Essentials course. It defaults to opening up in Nano, and again, this is going to be fine. This is going to be really simple. We can define our common settings in systemd files through the unit header. And in here, we're typically going to have our description. So I'm going to put a description equals, and then we can have our backup, the etc directory. Remember, this isn't the timer, so we're not going to specify when it's going to be backed up. We just need then our service element. And again, this is going to be very simple with an exec start. And if you think if we're going to be backing up the etc directory, we're going to be using the tar command. So we can go through and specify tar -c to create, z to compress, f for the file to back up to. And we can back up to our root user's home directory and the etc.tar.gz. And of course, as we're saying, we want to be backing up the /etc directory. Now that's all that we need. We don't need to go through and put our install section in because we will not be enabling this service. So we can use our Control and X, Y to save and enter on our file name. And there you go, we've created it. But we can check the validity of this file using our systemd analyze. We saw the analyze command before where we could look at our boot process, but we also have then systemd-analyze and the verify subcommand. With this then we can go through and look, I've got the name of the file to verify, so I might as well just copy this across. As I go through and look at it, we're getting some spurious errors that are nothing to do with the backup.service. So this is generally good. But to prove that it is working, there's nothing stopping us generating an error. So if I quickly go back and edit, let's remove the E from exec start, go back and save, so Control and X, all of our normal things while we're writing back, run the verify again, and we can see now that we're definitely getting errors relating to the exec start. So if we fix this up, put the E back in, and then we know it's going to be working again, When we go through and verify now, we can actually then prove that the verify is working because we're not getting the errors that we saw before. So it's a good check, but we just have to be a little bit careful about some of these spurious errors. Now, we're not going to start or enable our backup service. We're going to go back now and change our edit to be the backup.timer. With this, we're going to add in our unit section, and in our description, we can probably go through and say that we are backing this up once a day, because this is our timer, and we can explain our timer settings. So as I go through and put our backup, daily, the etc directory, and again, we know the spelling of the description doesn't really matter, but we might as well tidy it up. And again, we don't need much else in, but we need to put in our timer section. It's the timer section that controls when we execute. So we can go through and put our on boot sec equals, and then we can set it to 5 minutes. So 5 minutes after boot. And we can make sure then that it runs regularly by putting an on unit active sec. But if we change this to activate sec, we can build in an error so we can verify this error as we go through. And I'm just going to put in 24 hours. Remember, this should be on unit active sec. And we can go through and specify the unit. Now, we will default to looking for a backup.service, but I would prefer to explicitly put it in just so we've got a little bit of documentation. Under the install, we do want to enable this. So on system startup, we will be then running the timer unit, and we're going to put it wanted by the multi-user.target. Targets, remember, are grouping our services together, and we can use our control Linux and jump out and save our file. Now remember, we built an error into this, so if we go through and verify the backup.timer, then again we can see that we're ignoring because we don't understand that section. So if I go back and change that from activate sec to active sec, so let's drill back, edit our file again, correct the error. So this should be active. So we want to run 5 minutes after boot, but then 24 hours after the service was started. So it's going to be running once a day, but it's also going to run 5 minutes after boot. As we go through and check it again, it all seems very good. Now remember, it is this timer unit that we need to enable. So sudo and systemctl enable, and then our backup. If we don't do the minus now, it's not going to run at this moment. But we don't need that to happen, because what we're going to do now is actually go through and reboot our system. By rebooting our system, we can prove then that the enabled timer unit is going to fire automatically. So connecting back into my system and taking a look at our systemctl and list-timer, we're able then to see, look at the top line there, we've got 4 minutes and 36 seconds left, and then our backup timer is going to activate our backup.service. So we can see how our timer units can be created, as well as the reporting information that we get back from those units. As we pointed out at the beginning of this presentation, the very traditional way in Linux to manage regular scheduled tasks is through the cron daemon and cron tab files. We have both user crons and the system crons. We begin by taking a look at our system cron. If we go through and take a look at the file /etc/cron tab, this is our main system cron. From here, we can go through and search for the commented lines. We're explicitly looking for lines beginning with a comment. This is then going to show me the documentation. Now, ideally, we don't write through to this file, because if ever the cron daemon is going to be updated, the cron tab file might be overwritten. So we're normally going to use the extension directory /etc/cron.d. And in here, we can create our own cron files. We can use then the editor of choice. I just happen to be using Nano here, and we're creating a file called test. Inside of that, the entry looks a little bit cryptic, doesn't it? But it's not too difficult once we get used to it. And don't forget, the grep command that we issued earlier would have shown me the documentation. But here, the first column represents the minute, and we're saying every 10 minutes. The next column is the hour, so we're saying every hour. The next column is the day of the month. This will be 1 through to 31, and again, it's every day of the month. Then we're looking at the month, 1 through to 12. And finally, we have the day of the week. This then can be set to 0 through to 7, and that's not a mistake. Sunday can either be 0 or 7. We're running as the root account, running the date command, and appending to the file /temp/date. So once this has been running then for a little while, we should have multiple entries, each showing the date the entry was made inside of our temp and date file. But this is our system cron tab, and it's managed by the root user. But each user can manage their own cron tab file, and that's done through the cron tab command. Crontab -L will list a user's cron. Crontab -E will allow a user to edit their cron. It's written in the same way, but there is no user field. If we wanted to remove our cron tab, we could use crontab -R to delete the cron tab file for our user account. And you know what I'm going to say now? The very best way to learn this is by moving out to our command line, so we're able to interrogate these files ourselves and create our own entries. So in the next clip, we're going to dive out to our command line so we can learn a little bit more about regular tasks being scheduled using the cron daemon. And yes, we're going to dive out through to our command line, and we're going to look at managing our cron jobs, both system cron jobs where we're running as the root user, as well as our user crons. So come on, let's find that command line. And here we are at the glorious command line of our Ubuntu One system. We're about to dig in a little bit into the cron daemon. We can begin by looking at systemctl and the status of the service cron. It's a good idea to check that cron is actually running. Look at this, it's both active, so green, so that's good, but also check that it's enabled. So it's going to start on system boot, and of course it is enabled and running. So this is a good start. We're also able to see some of the log entries that have been produced by the cron daemon. As we go through them, we can take a look at our cron file. We'll be taking a look at our system cron file. And if we use grep, but we're deliberately going to be looking now for commented lines so we can see the documentation. So if I look for lines beginning with our comment from the system cron tab file, so /etc/cron tab, then yes, remarkably, we see the comments. This is often what we don't want to see, but we can see then how we can create a cron entry and the explanation of the fields. But importantly, We can also view that we shouldn't be editing this file because it could be replaced in an update. We're going to be editing files underneath /etc/cron.d, and that's exactly what we're going to be doing. So for us to create our sample entry, we can use sudo and whichever text editor we want. I happen to be using Nano here. And we can go through and open up the /etc cron.d subdirectory, and then we'll just call it a file called test. That's a good enough name for anything, isn't it? But once we open up this file, of course, we're going to be a little bit on our own because it's a new and empty file. As we write our entry, the first column is going to be the minute. When do we want it to run? If I put 15, it would be quarter past the hour. If I put something like 5,25, it would happen at both 5 past the hour and 25 minutes past the hour. We could also go through and put something like this, where we put asterisk for every minute. But if we go */10, we're specifying every 10 minutes. The next column will be representing the hour. We can specify that we want it to happen perhaps between 9 and 5, but we write this in a 24-hour format. So it's going to be 9-17, between 9 in the morning and 5 in the afternoon. Then we're looking at the day of the month. This will be 1 through to 31. And we can say any day of the month for any month and any day of the week. Now, being a system cron, we have to specify the user account under which the task is going to run. So we're going to say this should run as root, and we're running the date command, and we want to write to the file /root/date. And of course, we said we want to write to this, I mean append, so let's go through and do a double greater than. So once it's been running a little while, we should have multiple entries, but we're probably not going to hang around for it to run multiple times. Once we're ready, we can use a Control and X and go through and save our changes, and we're ready to go. But it's not going to happen straight away. We've got to wait 10 minutes. So we can leave that to cook in the background. But whilst that is cooking in the background, we can move ahead and take a look at our wonderful user crons. So not just are we restricted to what the root user can do, each user can create their own scheduled jobs. Maybe a good idea, maybe a bad idea. A lot just depends on what your users are able to do. They're managed through the crontab command. Crontab -L is just telling me that I don't have a crontab at the moment for the user vagrant. But we can go through then and use crontab -E to edit. Often the first time it will run, it will prompt you which editor you want to use. But I'm using Nano. But again, you can use whichever editor you want. You can also set the editor variable to make sure that it's defined within your login scripts. I'm going to go through and put the same style of entries in. The only thing is going to be different is that we don't need to specify the user account. So I'm going to specify every minute, of every hour, of every day of the month, of every month, of every day of the week. There is no user account, so we put our command then directly after those 5 time elements. And again, I'm going to be running the date command, and I'm going to append it to the /temp and date file. Now this is going to be running every minute, so it's going to happen a little bit more quickly than running every 10 minutes as we saw before. But once I'm happy with my entry, I can use Control and X again to save my change and jump out of my file having saved it. And that's going to be in place ready for me to use. But we also need to understand how we can go through and check this. Well, let me take a look at the journal.ctl, our journal log. If I use sudo and journal.ctl and -F to follow, we're going to see the current 10 lines and continue to follow the end of our journal log. Now we can see then the entries there as a Vagrant user was beginning to edit their cron tab file. We can see the session that I've opened to gain sudo access to follow the journal log. But within a minute, I'm going to be able to see my job actually executing. And this is why we're following it. We can see then from cron, our Vagrant user, the command, and what they've actually issued. So we've created a new session for Vagrant in the background. I can use Control and C to stop following my file. Now at this stage then we've verified that our job has run for our user. I'm ready now to remove that, so cron tab -R. That way I don't have to worry about every minute we're writing through to the file. So let's clear that and get that tidied out of the way. But we also need to check from our root user's perspective that the system cron had run. So if I look at sudo -I, if I go through and run ls, well, we can see the system timer job that's run the backup, our etc.tar.gz, but we don't have the date file just yet. Remember, that should be running every 10 minutes, but it runs on a 10-minute segment. So if I go through and look at the current date, we're going to be able to work out when it should be running. So a very quick execute of the date shows me it's 13:34. So that means it should be running at 13:40 on the 10 minutes. Now, I don't want you guys to necessarily be waiting, so I cut a little bit of time out. When we look at the date now, it is 13:40. And when I do a listing, we can see then I've got the date file. And of course, then as I cat out the date file, we will see that it was written to at 13:40. So how's that? There you go. We've got our cron system up and running, and we understand about our cron tabs. Now, if we do need to schedule a task, but that task is likely to be only run once, then probably we need to be looking towards the at daemon. We need to make sure that it's running and enabled. ATQ will allow us to query any at jobs that we have. We can specify jobs by using a simple time structure such as at noon or at tea time or at midnight. We can also specify it with a more accurate date and time notation. But once we've created our job entry, it's important to know that we use Control and D for Delta, Control D, to be able to end the editor. But looking at a more formal notation, here we're specifying, obviously you can see 10:51 on July 25th for 2023. But again, once we get into the editor, we can add any tasks that we want to run at that date and time, and then use Control and D Delta to be able to exit the editor. ATQ, again, is going to list any jobs that we've created. If we need to delete, let's say, that second job, we can check the job number, it's probably job number 2, but run ATRM and then the job number. If we want to look at the job detail, we can use AT -C and then the job number. You'll get a very verbose output, but towards the bottom should be the details of our job. Let's move out to our command line and look at working with at. And look at this, the space and time for learning at. We're first going to start by checking systemctl running as the root user. We know the importance of that when we're checking our status so we can see any log entries for the service ATD. So this again is good. We can see active, but looking above that, we can also see that the service is enabled. And that's really important because obviously we want it running now, but we want it running on system boots. We can use ATQ as a standard user to query our own job queues. And currently I don't have any at jobs defined. I can define a job by specifying the time I want. In simple format, I can put something like tea time or noon, and it's going to run then at that set time. Tea time is quite cute, 4 o'clock in the afternoon. All Brits apparently stop at 4 o'clock for tea. I can run the command date and any other commands that I want, but importantly, we need to remember how to leave the editor, and that's Control and D for Delta. Now with that done, our job is created. ATQ will show me that the job has been created and it's going to run at 1600 hours. We didn't specify the date, so it will be the next 1600 hours. As I go through, if I want to specify a more accurate time, I can then go through and specify the time and date that I want. We could always look at man and at to see the time format, but I'm going to specify 3:31. That will be 3 a.m. And we can go through and specify August and then the date we want, maybe the 23rd, and the year, maybe 2024. We can now start writing our commands, but this editor is quite limited. So if we start typing a command, maybe we want to go through and list the etc directory. So I can then type the command I want to execute and any arguments. So let's go through and write ls and then /etc. But if I make a mistake, I can't backspace. I see those Control H's, but I'm unable to edit my commands here. So it doesn't matter, I'm kind of stuck. But don't panic too much. Just go through and use Control and D to end or exit your editor. We can look at the detail of what we've actually created. I can use an AT-C and then job number 3. And look right towards the bottom, we can see the details of my job. So it didn't have any of those extra spurious characters, but we've got E, T, Y, and C. So it's important if we make a mistake not to panic. All we need to do is delete that entry, so ATRM3, go back and recreate the entry. Presumably it's going to be the same date and time. This time just take a little bit more care adding your entry in. We can add one or more entries in. So let's go through and cat the etc host file as well. Control and D to end my session. And we can see that's job 4 that's going to run at 3:31 on August 23rd, 2024. ATQ again will list all of the jobs in my at queue. This is for my user account. And I say if we want to look at the details of that job running in 2024, then we saw before we can use AT-C, the job number, and look towards the bottom, and we can see what's actually going to execute. So don't be put off again by the detail and the verbosity of the output. If we want to remove entries, as we saw before, I can do ATRM and the job number. And then we can always go back and use ATQ to see what's been left. So we can see this one is going to run at 14 or 1600 hours. My 24-hour clock. But that's 1600 hours, so 4 o'clock this afternoon on August the 26th. So hopefully this gives you an idea of some of the things that we can use using our @daemon and look at scheduling tasks that we don't need to run on a regular basis. But let's return to our slides now so we might just summarize a little of what we've seen. Now, just a quick reminder that we do have a Git repository where you're able to download the samples that we've been working with. Especially when we look at this module, you're able to get your timer unit and your service unit for when we were looking at scheduling with systemd timers. Yes, that familiar orange background and the sunset on another module. Now, I'm Andrew Mallett and I'm your instructor. I really hope that you found this as being useful, because if you haven't, let me know. It's really important that you're getting the most out of it. So let's just remind ourselves of what we've looked at. So it's all about scheduling tasks in Linux. As we go through, try and think if you really understand the topic. If you don't, you can always spend a little bit more time going back and reviewing it. And remember, the man pages and the help options can be really, really useful too. But we looked at systemd timers, the latest and greatest, the newest on the block, part of that fabled systemd ecosystem. You know I love that. But what did we do? Well, we created a service unit. The service unit is going to be triggered by our timer unit. The timer unit has all of the time data of when we want the service unit to be executed. And it's the timer that we go through and enable. So just make sure we understand how they all fit together and which one needs to have the install element in it. The install element goes into our timer unit. Any unit file that we have created, we can always go back and use our systemd analyze and the verify subcommand, so we can check that it's all going to be working before we try and execute any part of it. And then we take a look at our standard way of scheduling tasks. A lot of your traditional Linux administrators are going to be very familiar with the cron daemon, and of course they're going to be committed to that way of doing things. So for a long time you are going to be associated with cron jobs, but maybe at some stage in the future the systemd way of doing things might become the prevalent and most dominant way of managing your scheduled tasks. But with cron, we have the etc crontab file and its extension directory etc and cron.d. But remember the importance of not using the crontab file, because a package update to cron could then overwrite your crontab file. User crons are managed through the crontab command. Remember, we can use crontab -e to edit our own entries, -l to list our entries, and if we want to remove all of our cron jobs, we can use crontab -r. Finally, we looked at the @daemon and the command @. With this, we're not really scheduling our regular tasks, but those tasks that we want to run on occasions. So maybe migrating data, but something that's not going to run on a regular basis. Hopefully, as I say, this gives you a great idea of what we've looked at, and you can identify what you're confident on and maybe what you're least confident on. But if I haven't done my job properly, then also let me know. But we're not quite finished yet. Oh no, we've got a little bit to run through in this course. Next up, we're going to be taking a look at monitoring processes within Linux. And I really look forward to joining you in that module so we can learn all about the top command, the ps command, the uptime command, and the associated elements that fit around that system. Hello and a big warm welcome to you to this Pluralsight presentation. A presentation where we're going to take you through the module Monitoring Processes in Linux. My name is Andrew Mallett and I'm going to be your instructor for the duration of this module. So come on, let's make a start. As we work our way through the module, we're going to be taking a look at monitoring processes and performance in our Ubuntu 2004 system. We can begin by taking a look at an issue we've already identified with the multipath daemon that we have in our Ubuntu Vagrant image. We're going to be taking a look at viewing the processes by CPU and memory utilization, listing our process status, that's the ps command, sharing our CPU more nicely by making use of the nice and renice commands, and we'll be looking for how we can search and end processes. Now, to begin with, as I say, we have a little bit of a problem. We've already looked at when we were seeing our logs that we're getting an awful amount of errors produced by the multipath daemon. we're going to look at reconfiguring that so it's going to work well for us. The multipath daemon is responsible for establishing multiple paths and topologies used to connect to storage devices. We've only got local devices, so we don't need to worry about this. But our local drives, SDA and SDB, haven't been excluded from multipath D. So we're getting errors saying that we can't locate the path to these storage devices. To reduce the amount of errors, there's a couple of things that we could do. We could just disable our multipath daemon because we don't need it, or we could correct the configuration file. But if we just correct it in a running image, the next time we clone our image again, we're going to get the same error. So we can build it into our imaging process. If we go through, first of all, identifying our image problems, we can go through and use journal.ctl to list the unit multipath D, and we can follow the end so we can see them constantly writing. We can also see the errors by looking at the status of the multipath daemon. And if we want to know more about configuring multipath, we can put it through the man5 and multipath.conf so we can understand what's available to us. Now, if we want to edit this, we can go through and edit our multipath.conf, but obviously we have to understand the configuration changes to make. And we're going to be making the changes through Ansible. In this way, every time we start up our image, even if the image hasn't been started before, we're going to be checking to make sure that our mitigation, our fix, has been put in place. We need to add in a task, and this task is using the Ansible copy module, and it's copying across the multipath.conf. Rather than define it as a file itself, we can deliver it dynamically through content. Now, these are YAML files, so they are space sensitive, so we do need to make sure that everything is indented the way that we have here. But don't forget, we have also got this available through our course downloads and the course repo. So you can make a copy of this if you don't want to edit the file dynamically yourself. But we're going to move out to our command line now so we can identify the problem and, more importantly, fix the issue. And hello and welcome to our first demonstration for this module. Well, we're going to be working on our Ubuntu One system. We're going to begin by investigating our multipath daemon and making sure we understand the error that we are facing. With that under our belt, we can look at correcting and mitigating our issue using the Ansible playbook. We're using the Ansible playbook as a provisioner inside of our Vagrant file. The Vagrant file controls our Vagrant machines, and we can make sure that the playbook is executed locally via Ansible on our guest machines as they boot. So why don't we go through and look at our Ubuntu One system so we can see the error and know how to fix it. So here we are then on Ubuntu One whilst it's not been fixed. So we're going to get our multipath errors. We know we can check our journal log using sudo and journal.ctl. When we go through and take a look at it, if we use the -f, we will follow. So we'll be continually looking at the log. -u specifies the systemd unit we want to look at. And we're going to be looking at the multipath d.service. .service is assumed if we don't put the unit type in. Hitting the big enter key then, we're able to see the errors that we're currently getting, and of course following the file as more errors are added from the multipath daemon, we're able to see it. It's all to do with our SDA device and our SDB device, and we don't have the correct configuration for these, as these are local drives, not networked storage devices. So I can use Control and C to get out of this following. And obviously it's this that we want to fix. But if we take a look at the man page, the manual page, man 5 is looking at the documentation for multipath conf. When we look at this, this is the configuration file that we can use to add exclusions. The exclusions are added through the blacklist, and we can see then that we can add in a blacklist to exclude devices from discovery. So this is what we need to be able to do. But if I just went ahead and edited the multipath.conf on this system, I'd need to do it on Ubuntu 2 as well. Anytime that I rebuild my machines, and generally I rebuild them for each module, then I'd need to edit them again. So we really want to look at the provisioning of the virtual machines and fix it during the provisioning. And for this, using Vagrant, we can look at our Ansible_local provisioner. The provisioner is going to be defined within the Vagrant file, and even with our virtual machine booted, we're able to access our Vagrant file. If I look at nano/Vagrant, the Vagrant directory is mapped through to the directory that we launched the virtual machines from. So the working directory on the host where we started our virtual machines from. The Vagrant file with an uppercase V then defines the configuration of our virtual machines. The common settings that we use for both of our virtual machines are listed first. And here we go through to our Ubuntu Focal 64 virtual machine, but then we go through and specify the provisioner. Ansible_local will ensure that Ansible is installed on the guest machines and then plays the ubuntu.yaml file. And it's this file where we can define any configuration changes that we want. We'll take a look at this now. So going through and opening up from that same directory, the ubuntu.yml or YAML file, we can see the configuration that we've got so far where we update our package cache and we allow password-based authentication for SSH, where typically it's been disallowed. And we've got our handler at the end. The handler is there to restart our services. So I'm going to add in a new task. Now, all of these tasks and the format of a YAML file are white space sensitive, so make sure that they're all lined up nicely with spaces. So we're adding a new task. The name we're just going to put as edit multipath. We're going to be using the copy module from Ansible, and copy should be lined up with the name of the task. Inside of our copy module, to specify that we are working with properties of copy, we're going to go through and line up with the P, so 2 spaces inside of copy, and we can go through and add in the destination. The destination is going to be the file that we need to edit, so /etc/multipath.conf. And rather than use a source file that we can copy across, we only need to specify a few lines, so it's easy done through content. Content is followed by a vertical bar. This is our fold operator, which then ensures that we read the carriage returns that we add in. So I can define multi-line content that follows. This again should be 2 spaces inside of content. So lining up with the N of content. And we can then go through and specify the file contents that we want. And it's going to begin with defaults and opening up our brace brackets. Inside of this, again, making sure that we're all lined up nicely. We're going to put our user-friendly _names, and we can turn this on. This is what would be in our configuration file in any place, so we want to maintain this. We're replacing the complete contents of our multipath.conf, so we're also then defining the original contents. We can move in to make sure we end then our brace brackets. That needs to be lined up with the left-hand side of the file, which is the D for defaults. Then below this, we're adding in our new content, and this is our blacklist And with this, we're going through then and adding in the dev nodes, the device nodes that we don't want to be included in our configuration. And with this, we can say beginning with node name is beginning with SD and then A or B, A through to B. And then we can close off our regular expressions. So this is going to work for us, device SDA and SDB. We can close off then our brace brackets. And that's our content defined. The last thing we want to do is going to be a property of the task. So we want this lined up with our name and copy is the notify. With notify, we're going to specify that we want our service to be restarted, and that's the multipath service. So we're going to go through and just call the handler restart MP. We want to make sure that notify is lined up with copy and name. And when we look at that, we're probably one space out, so just make sure that it's lined up nicely. As always, though, these files are available to you through the course downloads or through the course repositories. So we can add in a new handler. Handlers, unlike tasks, don't run automatically, only when they are triggered through the notify. So we can call this then restart MP. It must match the name that we've assigned underneath the notify. It's going to use the service module. With this, and we have specified the name of the service to work with. And with this, and we're going to set it to our multipath D, the name of the service that we need to manage, and the state that we want. With this, then, we're going to put our state to be restarted, which is why we don't want it to run all of the time. We only want it to be restarted the once, not every time the playbook executes. We can then go through and save our change, and we should be ready to go. I'm going to exit out of my virtual machine. But remember, when we were editing the files, we were looking at our working directory. So the Vagrant file and the Ubuntu.yml file that we see now are the files that we saw from inside of our virtual machine. I'm going to destroy my virtual machines. So this is then deleting the cloned images. And then I just need to bring up my virtual machine again. This will reclone it and then run our provisioners. So we can see as we go through, we're installing Ansible into the guest machine. Once Ansible is installed, then we can see the playbook is executed. So we see the update of the package cache. Once this has been updated, we'll run through the rest of the tasks. And we should be able to see then the configuration going ahead to allow password-based authentication with SSH. And then, as we can see, we're editing the multipath configuration and then restarting both the SSH daemon and the multipath daemon via the handlers. So we should be up and running now. It just then leaves us to go through and make sure that we can connect back into our virtual machine. So this is where we can go ahead and use the Vagrant SSH to Ubuntu One. And then from here, if we go through and use sudo and journal CTL, we can always add to switches that we saw before. I can specify to follow, so -F, but don't look at any current content, only look at new content, -N0. For our unit file, the multipath. So this is good now. When I go through and look for the multipath D, we're not seeing any new entries being added. Whereas before, we would have seen all of those errors being generated. I can use Control+C to stop following. If we want to double check, I can go back and take out the number of lines to follow. So it's following the default of 10 lines, and we can see our multipath daemon was restarted, and we're not getting errors since the restart. So hopefully this is giving you a little bit of an understanding of how we can look for errors and then provide during provisioning scripts ways to mitigate those errors without needing to go back to the original image. We're now going to take a look at the performance of our system, and we can do that by using the uptime command and taking a look at our averages. The first thing, though, we should understand about our load averages is that we need to understand how many processes that we have. Simple command mproc will show us the processor count that we have. When we look at the uptime, it not only shows me the uptime, but it shows me the load averages for our CPU over the last minute, 5 minutes, and 15 minutes. But as I say, to understand the value that we're looking at, we have to know the number of processes that we have, and we can then divide the value of the load average by the number of processes that we have. This looking too difficult? Sounding very difficult to me. Believe me, though, it is simple. Come on, let's go out to our command line and take a look at this whole idea of CPU utilization and uptime. So we'll look at how we count our processes and calculate these load averages. But it's simple mathematics, believe me. And here we are at the glorious command line, a command line that's going to expose to us the number of processes that we have. So mproc is the simplest way to do it. Another way that's going to be more verbose is using lscpu. With lscpu, we can see we've got a lot more information coming out, but we're going to have to step back and scroll back to see the number of CPUs that we have. So CPUs and 2. So you can see why I like the simple mproc command. When I go through and take a look at the uptime, look at my system at the moment, it hasn't really been that busy. The output includes the current time. We can go through and see how long we've been up, so 3 hours and 6 minutes, as one user connected. And then we've got a load average, and the load average we're looking at shows over the last 1 minute, the last 5 minutes, and the last 15 minutes. But without understanding how many processes we have, we can't really determine how busy or how large a number we can have in those columns. Where we have a process count of 2, where we have 2 processes, we can go up to 2.0 in any of those columns. Above 2.0, we will then be taking a look at queuing processor calls. So we're unable to deal with requests as they come in. They have to be queued. Now, this might be fine if we're looking at it for the last minute, but if we've been queuing so higher than 2.0 across the last 15 minutes, then obviously something bad is going on. We can look at increasing our CPU load. If we go through and do something like tar minus C to create, we'll use extreme compression, so we're going to be using a lot of CPU time, and we're going to be writing to the file, and we'll write to the file, let's say share.ttar.xz for our extreme compression, and we're going to be backing up the usr/share/doc directory. We'll send all of our screen output through to /dev/null, and we'll run this all in the background. So we get our prompt coming back. I can go through and then run it again, run it again, run it again, run it again. And believe me, we're going to be really starting to stress our CPU now. If I go through and clear my screen and go and look at uptime, we can see then that we've gone to 1.19. Let's go through and queue up a few more events. And then what we're going to do now is Control and L to clear my screen. And then if we can go through and watch uptime, we run it every 2 seconds. So we see our load average now has gone up to 1.54. So, okay, it's dropping down to 1.42, 1.31. But we can see then where our CPU is getting busy. But remember, we can go up to a maximum of 2.0 here before we need to be concerned. But it looks like we're probably tailing off now from a lot of the work because we're reducing. So once we get now down to 0.93, we're less than 50% utilized, remembering that we can go up to 2.0. When we look at it across the last 5 minutes, again, we're up to 0.42. So that in itself is probably only 25% utilized. Over the last 15 minutes, 0.17. So really not that busy over a 15-minute period. But we can see as we start adding stress to our CPU, we can start seeing those values go up. But to understand how we read those, we do need to have a good understanding of what's actually happening with our CPUs and how many CPUs we have. I'm just going to use a Control and C now to stop this. And we can see then that all of our backup events have now completed. Next on our agenda is the command top. Top is a really good summarizing command. We can run top by itself and it will open up and give us a menu. By default, it is sorting via the CPU utilization. So we'll see all of our processes that are running, but the most CPU intensive ones will be listed first. Using the F key, F for fields, we're able then to change which fields we're sorting on, and we can go through and perhaps choose to sort on those using the most memory. But again, the best way to be able to see this is to dive out to our command line, a command line that I encourage you to visit too, so we can see how to use the top command, using top and sorting by memory utilization, as well as the default CPU utilization. And here we are, and all we need to do is type the command top, T-O-P. Now look, we get a summary straight away. We get to see our uptime information. We get to see how many tasks are actually running on our system, our CPU utilization, and our memory utilization. But because we're sorting all of our processes by default using CPU utilization, that probably is changing quite a lot. So we can see that our display is changing reasonably frequently. The moment it seems to be system D that's taking most processing time, but it can change very quickly as we start looking at other processes, such as top, which is taking most now. If I hit the key F, so I'm just moving my finger to the F key, pressing the F key, we can then see the fields. We can choose to include more or less fields, but for the moment, I'm just going to arrow down. So we've selected % memory, and I'm going to use the key S, S for sort. With that done, I'm going to use then Q to jump back. And now we're sorting based on memory utilization, and this tends to be a much more static display as the memory utilization is far more consistent than the CPU utilization. And we can see it's the Snap daemon, one of our package managers, that seems to be taking the most memory at the moment. But we can also see there's the unattended upgrade, the path, the multipath daemon. Again, it might be an idea if we don't really need the multipath daemon to disable that service if we don't really need it to be running. Once we're finished, we can change back if we want, so F, and then up arrow key to our CPU, and then S for sort, and then Q, and we're back now sorting on CPU utilization. When we're finished, we can use Q to jump out of the top command. Working with Linux systems, we've typically been able to see our process status using the PS command. Typing PS by itself will list processes involved in our current shell. Using PS-F, we're able to do a full listing, but it doesn't quite stop there. As well as a full listing, we also have a long listing, the -L. We can combine them together as well. If we want to see all processes, we can use -E. So -E for everything, if you like, and that's going to be processes within your current terminal, as well as other processes, even if they're not associated with terminals. Those are typically our background services that will be running. If we want to look at a particular process, remember process ID 1 is going to be systemd. Systemd manages all of our other services. We're able to use then -P and the process ID number. Each process will have its own process ID. Typically, we've been used to searching the output of PS-ELF to look for a process. So if we wanted to look for all processes running the bash shell, we could go through and use grep and bash. Now that's okay, but there is a newer tool, pgrep. If I use pgrep bash, we can go through and search for all processes with bash, but we don't show the actual search process itself. So it's a much better, more efficient way of doing it. One command and giving us a more effective result. As well as pgrep, though, when we want to end processes, we can go through and start up a process. Here, it's just a sleep process waiting for 1,000 seconds. We're running it in the background, and that's what the ampersand does at the end. Rather than going and looking for the sleep process with our pgrep, or even our PS, and then searching the output for sleep, we can actually combine all of that together in pkill. Pkill will go through and terminate the sleep processes. The default signal that is being sent is a terminate signal, but we can go through and investigate other signals by looking at the kill command itself. Kill -L will list all of the signals that kill itself can send. pkill is just an extension of the kill command being incorporated with PS and grep. Again, to get the best understanding of this, we're going to dive out to our command line to get some great hands-on experience. We'll be listing and ending processes using the PS command, pgrep, and pkill. And here we are at our glorious command line. A command line we can begin by typing PS. Typing PS, we can see then our bash shell and anything else that is running inside of our shell. Now that includes the PS command, but obviously the PS command now has finished its execution. Any process that is currently running is going to be listed underneath the /proc directory. So if I go through and run a listing of the /proc directory, we're able to see a whole load of numbered directories. They represent our current running processes. Now we've got some magic that can happen here. We can actually move into our own bash shell directory by doing a cd /proc. So that then takes me to my proc directory, but we've got a magic variable $. $$ contains your current process ID. So even though, of course, our bash shells are all going to have different process IDs, the magic is now happening as we expand that variable. We see that's taken me into the directory 14931. Now, this is all very good, and it gives us an opportunity to be able to look inside of this directory. We generally don't manage our processes from inside of this directory itself, but it is available for us to go through and take a look at. It helps our understanding, if nothing else. But let's move back into my home directory, clearing the screen. If we want to look at a little bit more, we can go through and maybe look for our bash process. Typically, we've been using the PS command by itself. We can start extending this a little bit by having a full listing or a long listing. Now we can see then they give different interpretations of essentially the same thing, giving more detail with our long listing, but we can combine them together to get a long and a full listing. And this way we keep our user names rather than having the user ID number. If we want to look at all processes, not those just below my bash shell, it doesn't matter the order that we put it in, but we can put E in here for everything. And we're looking at all of our processes, including those ones that aren't associated with a current shell. Clearing the screen again will take me out of that. If I wanted to then go through and search for my bash shell, I can go through and run the grep and look for bash. Now this is good. I've got my result coming back, but not only has I got my bash shell, we've got the search process, my grep for bash coming back, because that in itself contains the bash string. So it's okay, but we have to be very careful about our results. Incorporating these two commands together, we get a magic command called pgrep. If I go through then and pgrep for bash, you can see I only get the process ID coming back for the bash shell. We don't see the independent grep process. So this is a much more efficient way of running it. If we wanted to get a long listing with this, well, there's nothing stopping me going through and running the ps minus L, P for our process ID, but we're going to return a list of process IDs by using the pgrep and bash command, and then we get a listing. In our case, it's the only one bash shell that we're running, but obviously this could be many bash shells. Now, if we want to look at terminating our processes, we can send signals to these processes. To work out the signals that we can send, we can use the kill command, kill minus L. The default signal is signal 15, or the sig terminate. If I go through and start a process, I'm going to start the sleep process. If I go say sleep 3, just to show you what it does, really just waits 3 seconds. If I wanted to run a little bit longer, then I go sleep 1000. But then I'm not going to get my bash shell back, so I can run it in the background by including the ampersand at the end of the command. So that's then running the command in the background, but of course it is still running, and PS will show me that because it's in my current shell. But if it wasn't in my shell, I'd need to be able to search for this. So again, I can go through and use pgrep and sleep, and we can get the result coming back. If I wanted to terminate this, I could then go through and use my kill and then the process ID that has been returned. So 15365. And now that has been terminated. If I go through and just run any command, we can see then any of my processes that have finished since I've started it up. And that includes then the sleep being terminated. So let's clear out of my screen. But there's a better way. Again, let's go through and start up our process again. And if I just go through and use the pkill and sleep, it then just sends the terminate process to the process ID that sleep is running, or multiple process IDs if we've got multiple sleeps running. As I say, the default signal is -15 for a terminate. But if it was not responding to a terminate, we might have to then really then terminate or kill our process, in which case we have to change our signal. So again, if I go through and run this again, sleep is running in the background. If I go through then and pkill -9, this is sending a kill signal. So instead of getting the word terminated, we're seeing now the process has been forced to quit through the killing process. Whereas the default method, when I go through and start it up again, if I physically go through and put -15, rather than just allowing the defaults to happen, we're sending a terminate signal. Remember, kill -L will list those signals that we can send. And what a terrific way to be able to access the documentation. But documentation in a really simple way, just seeing the pure facts that we need access to. But during this video, we've been able to take a look at our ps command, we've looked at our pgrep command, our pkill command, as well as the kill command that we're seeing now, so we can see the signals that can be sent to our processes. But for the moment, we're looking at moving back to our slides, so we might look at sharing our CPU utilization just a little bit better by using the nice and renice commands. Now, if you've already been working through these series of courses, you're probably aware that the course downloads are available through the Git repository. Now, if you don't want to become involved in Git, and that's quite okay, then you're also to download it in the traditional way using our course downloads from Pluralsight. We've been running through a course where we've been looking at monitoring Linux. And of course, you're now at that sunset page where you can congratulate yourself on what we've looked at. But only if you can remember what we have actually looked at. And what was that? Well, we started off by correcting the multipath daemon in Ubuntu 20.04. In our image, the vagrant image that we were working with, we have to exclude our SDA and SDB drives so that the multipath daemon doesn't try and build a topology of a network to connect to these storage devices. We needed to write through to our multipath.conf, and we were choosing the Ansible playbook to correct this. Now, you don't really need to understand Ansible for the Linux Foundation exam, but being able to understand Ansible is going to help you probably in your Linux career and maybe any DevOps options that you might want to look at. So it's not a bad thing to become involved in. And our course repository or the course downloads can help you both with the vagrant file as well as the playbook if you need a little bit help getting those set up. We then took a look at the uptime command. Not only can it show us how long our system has been up, but it shows us our load averages. But to be honest, those load averages we won't understand unless we know the number of processes that we had. In my virtual machine, I had 2 processes, so that would allow me a load average of up to 2.0 before I start queuing requests through to my processor. And remember, with uptime, we see our load average over the last 1 minute, 5 minutes, and 15 minutes. We then moved on to our process status command, PS, and we saw that we have options, -L for a long option, -F for a full option, as well as the option -P to list for a particular process ID or set of process IDs, and -E to list everything. We could use pgrep to search processes, and pkill to search and terminate processes. And don't forget, kill -L can list the signals that we could use to send through to our processes. And that's it, an end of a terrific module where hopefully you've gained a lot of understanding. But if there's anything you feel a little unsure of, then please connect to me. I'm at the Urban Penguin on Twitter or through the discussion fora. Also, if you need to spend a little bit more time going back revisiting the videos, really invest in your learning and make that time well spent. But when you are ready to move on, I'm going to welcome you to the next module, a module where we take a look at securing Ubuntu using AppArmor, a mandatory access control list that we're going to find commonly in Ubuntu and SUSE. Hello and a big warm welcome to this presentation from Pluralsight. My name is Andrew Mallett and I'm here as your instructor to help guide you through the module Securing Ubuntu using AppArmor. So when you're ready, sat comfortably, we're going to begin. And we're going to begin by just taking a little bit of an overview, a look of what we're going to be seeing during the module. So we're going to be understanding more about AppArmor, what it is, why we want it, and application security. We'll be installing any additional utilities that we want beyond the standard packages that are installed by default. We'll be looking at creating AppArmor profiles. Profiles then define what we are protecting. And we're going to be looking at how we can protect our own applications. And the process would be the same if we wanted to build profiles for any standard applications as well. When we look at AppArmor, AppArmor is a mandatory access control set, a MAC, application security that is promoted by both SUSE and Ubuntu. We'll actually see that many of the tools are authored by either Canonical and or Novell. Novell were the ex-owners of SUSE Linux. AppArmor works directly with the Linux kernel. Now that's important, especially when we're looking at log messages. The log messages are going to be generated by the kernel itself. And finally, we've got a little bit of a note here that it goes beyond our normal discretionary access control list, which of course can be bypassed by the root user. Many of our services will be running as the root user, so this becomes a really important way of protecting those services. So we can begin by investigating a little bit about AppArmor. We're going to find that it's installed by default on Ubuntu 20.04. So we can go through and look at a systemctl and status AppArmor, and we'll find that the service should be installed and up and running. Now, many of our utilities will need to be run as root. So if I try looking at the status of AppArmor with AA-status, we're going to get permission denied. Of course, we can then go through and rerun it with sudo. We can also go through and add in extra options. So if we just simply want to know how many enforced profiles are our rules that control what applications can do, we'll be able to go through and see this with AA status -- enforced. Those profiles are going to be located inside of our apparmor.d directory below etc. If we take a look at one of those profiles, we'll be able to use dpkg-s to look at the owning package, and we'll see that the package that installed that was AppArmor itself. If we want to look at the details of the package, then apt show AppArmor. So again, a little bit of a recap on some of the things that we looked at in our software management. Now, although AppArmor itself is installed, we probably want to go through and install some additional utilities. So we've got AppArmor EasyProf, which is a great way of creating profiles. AppArmor Utils, so an additional tools that allow us to go through and perhaps interrogate our log files. And AppArmor Notify, an easy way where we can go through and take a look at errors that have been generated by our AppArmor denials. Now, I think it's about time we put the brakes on these slides and dived out to our command line that I'm going to encourage you to join along with and take a look at installing the extra utilities we need and investigating the status of AppArmor on our Ubuntu 20.04 system. And here we are, ready for our first demonstration where we can get ourselves up and running with AppArmor. So we'll be installing any necessary utilities and checking the status. And here we are, basking in the glory of Ubuntu One, the command line that we're going to be working with for this demonstration. We're going to begin by just checking our service. AppArmor has a background service that will be started on system boot. So we know we can use our good friends sudo and systemctl status. And the name of the service is AppArmor. And of course, we don't need the extension .service. So when we take a look at this, it's enabled, so it starts on system boot, active but exited. Essentially, this runs, executes, and then jumps out again. We can double check this if we want by taking a look a little bit further. We can see the process ID was 508. If we interrogate that process ID, we're going to find that it's no longer running. So we're going to go through and use our PS command. And if we go through and take a look at -P508, then we're not going to get anything coming back. Now, we might be thinking this is just because I'm not running as root. Well, okay, let's do a sudo and bang bang, repeat the last command. But again, we're still not getting anything coming back. The process starts up, loads our profiles, and then it's finished. So this is quite correct. We don't need a long-running service sitting in the background. We can, though, go through and spend a little bit of time investigating our service by using the sudo and AA-status. Executing the command will go through and list all of the profiles that we have loaded, no matter the mode they are loaded in. We can see that we've got 28 profiles loaded in total, 28 of them being in enforcing mode. Scrolling down, we can see all of the profiles that are loaded, and these represent then programs that run on the system, and the profiles is a set of rules allowing them access to the resources that they need. We have different modes. We have the enforcing mode and the complaining mode. We'll see more details on these later, but if I want to, I can go through and list those that are in enforcing, or at least the numbers. So if I look at enforced, we have 28. Now we know that's the total number of profiles. But if I look at those in complaining, I don't have any. Enforced means that we prevent the action and log any denied action. In complaining, we log the denied action, but we don't actually deny anything. And it could be good in fault finding. So we can start understanding a little bit about our system now. And we can use the AA command, but we can also go through and use the app armor _status. So there are two ways to access these commands. It's really our choice and makes no difference. It's just different ways to access exactly the same program. So don't get confused amongst this. I tend to stick with the AA because it's shorter. If I go through and take a look at all of the commands that begin with AA, we see at the moment I've got a relatively small set. We can increase the amount of utilities that we have by going through and installing additional programs. So I can use my apt install. I've already done an apt update. I do that as part of my build process. And when we go through and take a look at the applications that we want to add in, we can add in apt armor and easyprof, so our profiling tool, app armor, and we can go through and add in our -utils. And the final one that we're going to add in is app armor -notify. Now the notify is actually going to add in quite a lot of programs. Kind of, if we want to see this, I might choose to remove the -y option, so we will get to see everything that is being added in. App armor notify can work with our graphical utilities as well, and as such is going to install a lot of the graphical environment, whether we want to use it or not. We don't have to use the graphical environment, so I'm not going to be too bothered about this, but just letting you know it's going to take a little while for it to run through. I'm choosing Y to accept the installation, and we can leave this to cook through for a little while. Now, once our deep roasted command line has completed its installation, we're able to go back and investigate some of those AA commands, so AA dash, and then just hit the double tab key. So if I go double tab, so tab tab, I'm able to see now that we've got a heap of extra commands, all beginning with AA, so extra AppArmor utilities that we've been able to install. Now, we won't be using all of these, but we're going to be investigating some of these commands as we go through and dig deeper into understanding AppArmor. So come back and join me soon. Now, when we're looking at AppArmor and trying to understand what AppArmor is all about, we could work with standard programs that we have on our system, but that would be too boring, wouldn't it? Why don't we go through and create ourselves a simple Python script and then look at controlling what that script is actually allowed to do? So the first part, of course, is to create the script. We can go through and use whichever text editor we want. We can use Nano, but if you're more competent, you might prefer to use Vim. But remember, especially in practical exams, don't get yourself tied down with the type of editor you should be using. Use an editor you are happy with. So we can open up running as sudo, and we're just calling the file usr bin file underscore test.py, py indicating this is a Python script. We can put our shebang line indicating we want to execute with Python 3. But although this is just the shebang, we also have to be very careful about what we need to do if we ever protect this with AppArmor, because we need to give Python 3, the executable, the correct permissions to be able to read and execute the script as well. So there's a little bit more than this than at first hits the eye. But we'll look at ways we can generate our profile later. Let's continue looking at our script. As we go through, we can see we've got a variable here that we're calling file, and we've got that populated with /temp/my text file. Now, this is a file that we're going to look at creating, so we're going to need access through to our temp directory and being able to write through to my text file. Again, if we don't have those permissions both in our standard discretionary access control list, but also within our profile, our mandatory access control list, it's going to fail. This is going to be really useful for us because we can make sure that the Python script is allowed to write to the correct file, my text file. But if anybody hijacks our script and tries writing to another text file, we're going to be able to stop it. As we continue, we've got a try block, so we can attempt to then open up our file for appending. We close it straight away, so we're not actually adding any content. But if we don't have the correct permissions, either as discretionary access control list or through our mandatory access control list, this is going to fail. If it does succeed, though, we can write to the screen that we have been able to create our file. And then we can move into our exception block. The exception block is going to be triggered if we fail to create our file. And we can write through to our screen saying that we, failed to create our file. So at least we can see something happening. We can also use an exit statement, so we leave with an error code of 1. Now this is our code, and this is all that we're doing in creating a very simple file. Once we've done that, though, we shouldn't forget to go and create the correct permissions. So we're setting this to be executable by everyone and readable by everyone. So on first thought, we shouldn't have any problem in executing this. We're going to double check that by going through running the program, and we're going to see that it works perfectly well and the file is created. But remember, at this stage, we haven't implemented the mandatory access control list. We're also going to go through and delete our text file so we can start afresh later on without the file being there and making sure that we can protect it fully using our AppArmor. Now, if you don't want to create the script, then that's perfectly okay. You're not necessarily going to be expected to write Python scripts within the exam. You are perfectly able to go through and download this both through the course downloads, but also my GitHub repository where it's available for you. And we're going to see that as we go through to our command line, which we're going to do just now. We're going to move out to the command line to create and test our Python script. We're going to be creating our file, usrbin file_test.py, and making sure that it executes okay before we try and break it all with AppArmor. So welcome back to the command line, and let's look at how we can download our repository. Remember, the repository has our script if we don't want to create it manually ourselves. So we're going to use git clone, pointing through to the repository server, github.com. And in there, we can look for the author, the Urban Penguin, and the repository LFCS representing the course that we're working with at the moment. Now we can see then that it's downloaded the repository and it's downloaded to the current directory. Look at this with ls, we're able to see the directory LFCS. We're going to copy then using sudo copy because we're writing to the usrbin directory, and we're going to copy from the LFCS subdirectory, moving into the operating representing the course we're working with, usrbin, and then the script file_test.py. And that little beauty is going to be copied across to usrbin. So with that done, we're a good way there already. But let's just double check what we have inside of that. So if I use the command cat, I can move it to the top of the screen. Escape and dot brings up my last argument. And usrbin file_test.py, we can see then it's pretty much exactly the same way as we saw it from the slides. Don't worry about the prompt being on the same line as the end of the file. I just don't have a clear and empty line in my text file inside of the script. But this is the script. But of course, this script we need to have the correct permissions to. So I'm going to use sudo chmod 755, which is adding read, write, and execute, plus read and execute for others and the group. We can check that it now does execute as a standard user, file_test.py, and look, we've created the file /temp/my text file. If I look inside of the temp directory, we can see that it's there. Now I'm just going to delete the file to make sure that once we've protected this with AppArmor, we're able to go through and run everything again from the start. So I'm going to rm/temp and then my text file, and we're back ready to run again. But we're going to look now at protecting this through our mandatory access control list, AppArmor. So let's move back into our slides so we can really understand how we work with and create profiles to control the execution of programs on our system. Although in the background we do have our AppArmor service, the service is not long running. The service is there purely to load our AppArmor profiles, and the profiles are a set of rules that allow and disallow certain actions through AppArmor. Our profiles can be set to be in enforcing mode, and that's the default mode, where the rules are enforced and violations are logged. We can also set a complain mode. With this, there is no rule enforcement, but violations are still going to be logged, and this can be really useful when we're trying to get a new profile up and running, or if we're trying to debug an existing profile. The profile itself contains a set of rules, and this then contains the access that they are allowed to certain resources. These might be library files or other types of files within your system. But this is the content, the rules make up the content of our beloved profiles. When we're looking at creating an AppArmor profile, these are just text files. We could technically just create it ourselves, but there is an easy way to generate a profile, and that's using AA EasyProf. Now this just writes to our screen, so it's not going to do a lot. So I'm redirecting through to sudo and T, so we're writing to the screen, but also then the file. The file needs to be in our apparmor.d directory, and we can see that we've called it here usr.bin.file_test.py. The extra dots in the file name are actually representing the directory path where the executor would be. So just be very careful that we have got the correct file name when we're creating the profile. We can go ahead and check the enforced profiles. Our enforced profiles won't have changed. We've just created a profile, but we haven't loaded it. Now we could either restart our service, but that would be unnecessary because we have a supplementary command called our apparmor_parser. We can use either the option -A in this case to add a new profile into our running set, or we can use lowercase r. Lowercase r is always a good option because it can be used whether or not the profile already exists in memory. It's there to replace the existing one in memory, whereas -A is there just to add it if it's not in memory. So we can read in then our profile, now checking our enforced list, and we should be back up to +1 now as we've added in a new enforced profile. But in doing so, we've kind of broken our script. If we try and execute it, we're going to see now that Python 3 doesn't have access to execute our file. Now this is strange because we just saw that it was working perfectly. Nothing has changed other than apparmor. We can check our logs. Remember, all of our apparmor denials are coming from the kernel, so we use journalctl-k to print from our kernel log. -g allows us to search using grep, and here we're looking for apparmor denials, so apparmor equals quotes denied. Perhaps an easier way, though, but it won't recap what we looked at with journalctl. There has to be a reason to throw journalctl in this just a little way, but if we're looking at the specific way to look at is using then AA-notify. -s is really since, and since 1 day. -v for verbose, so we can see a little bit of details about the errors that have been produced. Now that we know about what's going wrong with our system, we can look at fixing it. We could manually try and fix it by adding in rules to our profile. So our profile will have some brace brackets representing the executable, and we can give the executable read access to itself so it's able to read it. Now this isn't going to be enough. We also have to give Python access to it, as well as access to certain library files that we're going to need. So we could find this very tiresome in adding in all of the rules. But there is a very easy way that we can go through and create our profile. If we take a look at setting the complain mode, we're going to be able to allow the complete script to execute properly. We will still be logging our errors, but we're not stopping anything from happening. So the first thing that we're going to do is set the complain mode for our script. With that, we can then go through and execute it, and it's going to execute through its entirety without errors. But all of those errors will have been logged. So if we go through then and use the AA-log profile, we can interrogate our logs and update our profile based on what it thinks should be done. We'll be prompted to answer certain questions, and once we've answered those questions, we can save back to our log. We can then go through and set our profile back to enforce mode, and we should be up and running. We will have tested it writing through to the file variable that's currently there, and if anybody tries to change that variable, that's going to be disallowed because we're only allowing access to the one file. And this is why we really have AppArmor. AppArmor can allow a script to do what it's allowed to do, but not what it shouldn't be able to do. So if somebody gains malicious control of our script, we're not going to be able to write elsewhere. But we really need to understand a little bit about this. So let's come back in our next clip where we go through and take a look at setting all of this up. And now to really understand AppArmor, we're going to create our own AppArmor profile and manage that so we're able to add in the correct rules to the profile. Now at this stage, we're going to be taking a look at creating and managing our profile, so really get into the nitty-gritty of AppArmor. So I really do suggest if you have got a system to follow through, you do. But let's begin by taking a look at AA-EasyProf. Here we're going to go through and create a profile for the executable usr bin file _test.py, our Python script. Now the output is just written through to the screen. It doesn't do too much. All it's doing is including a few abstractions. So the include statements are not actually comments, they are inclusions. So it doesn't do too much for us, but it's only writing to the screen. So we need to make sure that we redirect. So we're piping the output through to sudo and T. T will also write to the screen, but importantly, we can elevate our privileges so we're able to write to the file /etc apparmor.d. We can go through and take a look at our apparmor.d directory where our profiles are going to be stored, and we're going to store this based on the executable name. So usr.bin.file_test.py. So we're using dots instead of the / for our path separator once we get to our file name. Now again, it's the same information that we saw before, but we are able to go through and cat that file out. Cat escape and dot then allows us to go through and open up the last argument. But as I say, there's nothing really in this file other than a couple of include statements. When we go through and take a look at running our AA status, we're able to add in the option -- enforced to look at those policies that are enforced. We've got 29. At the moment, we haven't included the policy we've just created. Remember, it's the service that loads our policy, and our service hasn't restarted. To load our policy, we can go through and use apparmor _ parser. The option -r will reload if it's currently loaded in memory, or add if it's not. And again, escape and dot can take me back through to my file argument. With that done, when I go through now and look at enforce, we now have incremented from 29 to 30 with our new rule in place. With that in place, we can try and execute our script. And of course, now we're starting to get problems. But we're in enforcing mode. So we hit the first problem and we stop at the first problem. There could be many different problems. We're just stopping at the first denial. And this is where it can be quite difficult. A way around this, though, is to set our profile into that good and well-named option, complaining. If we set it into complain mode, it's not going to stop anything happening, but it's going to log everything that is being denied. So if I go through and use AA-complain, Again, I can use escape and dot a few times just to cycle through my last arguments to get to the profile name. In complain mode, we can execute, but we just log the errors rather than stopping those errors. When we check in our AA status of our complaining, we've got 1 in complaining. And when we look at our enforce, we've gone down now from 30 to 29 because we've set 1 to be in complaining mode. The idea of the complaining mode is that we're able to execute, so you can see everything now has worked, but all of the errors that were generated have been logged to our log file. We're able to read from the log file and actually generate a profile from our log file. So if I use sudo and AA-notify, first of all, we'll look at those log file entries. So AA-notify is used to go through and look at our log file for our denials since the last day. We can see we had 10 denials here. I've probably run this a few times, so we've got more than you might be seeing. But if we want to look at the details of those denials, add in the option -v. With this, we can see the denials that have occurred and how many instances of each of those denials. Rather than just look at the errors, as I say, we're able to take those errors and generate those errors into a profile. Now take a look very carefully as we run through this. The first one is then where Python is trying to access our script. We're going to choose the option 1 and A for allow to allow all of the Python code to be able to access it. We're then allowing access to the script itself, so it's able to read itself. So we can allow for this. Now on this last option here, we have to be a little bit careful. We could use the abstraction usr-temp, but that would allow any file within the temp directory. We want to change it to the more specific option of 2, where the owner is allowed write access just to the one file. So I choose option 2 and A. We've now made the change. We can use the option V to view the profile. If that looks good, I can hit Q to quit out of this. Once I've quit out of it, then I'm able then to use S for save. So just be slow on your menu so you're understanding what you're reading, and don't choose too many global options where they're not required. If I set my system back into the enforcing mode, so I change AA complain to AA-enforce, we should be able to see that we are still able to go through and run our script without any problems. So it's all looking very good. But of course, if somebody gains malicious control of the script and was able to change the path that we're writing to, so if we look at editing our script and changing that variable name, as I go through then opening up then my Python script, I can make a change to the variable. And if we then write, instead of to temp my text file, if we just try writing through to text file, and then Control and X to save and exit. Now as I go through and execute my script, we're going to find that it no longer executes, failed to create the text file. Everything else is allowed. It's just that final write that's not allowed. And to prove that it will still affect irrespective of who you are, if I try and run it with sudo and file_test, even for the root user, it's preventing the write happening. So we're able to control access through our mandatory access control list AppArmor to make sure that everything is protected in the way that it should. And look at this, the sunset on another module, but not just another module. You've reached the end of this course, so a really hearty congratulations and thank you very much for persisting with this and ensuring that you're learning so much. I really do appreciate the effort that you've put in. But in this module, we were looking at AppArmor and introducing to you the mandatory access control list known as AppArmor on Ubuntu 20.04. AppArmor consists of profiles. Profiles are text documents that control rules that certain programs are allowed to have access to. We were looking at our logs, and that's var log and syslog in our Ubuntu system. Everything that is being logged is coming directly from the kernel. But to be able to read that log, we can use our AppArmor utilities. So we can go through and use the AppArmor-notify to go through and look for log entries. We have different modes that we can configure our profiles in. So our profiles are enforced by default, but we can also set them to be complaining. When we're setting them to be complaining, we don't stop anything, but we log all violations. In this way, it does allow us to either generate a profile, as we've seen, or debug existing profiles to understand what's not being allowed and decide whether or not they should be given access. On the profile that we created, we saw that even running as root, if we're writing to the wrong file, then we're not going to have access. So this really emphasizes the importance of having something like AppArmor running on your system. But as I say, this is the end of the module and the end of this course. You've done a great job getting here, and you need to give yourself a fantastic congratulations, and I look forward to welcoming you to the rest of the courses that make up the Linux Foundation Certified System Administrator track.